Well, hello and welcome you to Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day, here in my virtual classroom. Step on inside, and we are in section 4.5 of the Big Ideas Math Integrated Math 2 textbook, solving quadratic equations using the quadratic formula. It's a big, messy looking formula. It has its purpose and reason, just like solving using completing the square. Quadratic formula and completing the square are the two methods you can use to solve any quadratic equation at any time, including ones that have no real solution, but for now we are going to make that conclusion and just state no real solution. Wait further on in the chapter till we start solving what are called complex or imaginary solutions. But we can solve any non-factorable equations this way, and quadratic formula is actually derived by completing the square itself. So have some respect for completing the square and have its use when you do. Quadratic formula, of course, also has its use, and I will be gladly using it here whenever they request it, which is pretty much probably the entirety of the section. Probably going to be a nice, very long video. We are going to get into it. Strap on in. And let's see. Now, I've been teasing quadratic formula for quite a while. Every time I say 4.5, 4.5, 4.5, here it is. This is one that students actually warm up to. Once you know the formula, you feel it's a safe haven to use. There are some, not intricacies to it, but there's some things you got to remind yourself of. You still got to simplify radicals, you still got to reduce fractions, and there are easier methods when available. So make sure that you're only using this kind of when you have to. In fact, I love what I'm reading right now, and hopefully we get to talk about this. Choose efficient methods for solving quadratic equations. You don't always use quadratic formula, but we're going to solve using the quadratic formula. Interpret the discriminant. This is a portion of the formula itself, and we'll get into that. I'm sure the book will, and I'll wait till they say it. And choose efficient methods. Hopefully they start talking about when you should choose what and why, and if not, I'll talk about it. So the two new terms are quadratic formula and discriminant. Here we go. By completing the square so they're telling you, by completing the square for the quadratic equation ax squared plus bx plus c equals 0, you can develop a formula that gives the solutions for any quadratic equation in standard form. This formula is called the quadratic formula. Now, before I move on to the formula itself, let's go back to this part here. The quadratic formula only applies when you have a quadratic equation set in, equal to 0 and in standard form. The fact of the matter is we can solve for x, and we've done it using several methods, if factorable, and by graphing and using square roots when b is 0, and by completing the square and making something out of this when we can. Well, you can use this with these letters as well and solve by completing the square, and when you get x by itself, this is what it looks like. Actually, there's something missing. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I forget if it was section 4.3 or 4.4, but there was a problem that actually got us to get this into this stage when it was kind of, I think it was 4.3, in a kind of messy part. And I said, we're not going to use that formula. Of course we are. This is the quadratic formula. It looks very messy. A can't equal 0, otherwise it's not a quadratic equation, and b squared minus 4ac has to be greater than or equal to 0 because we have to take the square root of, we can't take the square root of a negative number, which is something we'll get into later. Now, the formula itself, because they're going straight into it, guys, the formula itself, most teachers expect you to just memorize, and normally I say the word memorize as a very taboo term. It's not something that I'm very comfortable in saying all the time because I like to think of things as like we learn the reason for why this thing is and such. And here's the thing. There is a nice breakdown of this. How do I say it? There are ways to break down the appearance of the formula. The discriminant is going to be one part of it. And there's another part here, actually, when we go back. If you notice here, there is a part that says negative b over 2a. Now, we've used negative b over 2a before. That is the axis of symmetry of your vertex. When you add or subtract this certain amount over 2a, you're actually getting your 2x intercepts coming from the axis of symmetry. Kind of cool. So negative b over 2a exists in that thing. We've seen that before. Anyway, but teachers expect you to memorize it. So, and again, I say the term loosely, but I would say the same thing. It's the largest formula I would say that I would ask you to memorize in anything from integrated math. I mean, there are some big law of cosines is a pretty big formula and such, but it has its roots that we can kind of build off of. But this is kind of one of the bigger ones, but you use it so often you get familiar with it. If you're learning it for the first time, like anything else, use a mnemonic device of some sort. Sing a song. The two most common songs, the one that I did was Jingle Bells back in the day. X equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Or the It's a little sharp at the end there. Or the verse where you go x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. I mean, just like anything else, right? We learn the alphabet through a song, A, B, C, D, in the form of Twinkle, Twinkle, Little Star. Hope I'm not getting demonetized for anything that I say here, if not World Series clips behind me. One of the other common ones is Pop Goes the Weasel. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. And x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. You can do whatever you want with it and come up with it, but eventually turn it into a song. I'm sure you're going to learn it a little bit better. I'm sure every time that I write it these days, that Jingle Bells thing still plays in my head. It has to. Anyway, this is a part of the lecture portion, so I hope this is beneficial. But there is a plus or minus, and the book, for whatever reason, the PDF doesn't seem to have it, so I'm going to have to insert that every single time, even in the practice problems we do. So we're going to solve 2x squared minus 5x plus 3 equals 0 using the quadratic formula. If you notice, this is an equation in standard form set equal to 0. So when we do the substitution, take a look. B is negative 5, A is 2, B is negative 5, and C is 3 when you're in that form. So we're going to do negative b. That's the opposite of negative 5, which becomes 5, right? Then we add or subtract. We add or subtract the square root of b squared minus 4ac. Negative 5 squared is 25, minus 4 times 2 times 3, 4ac. 25 minus 24, which is 1. The square root of 1 is 1, and we're down with doing 5 plus 1 over 4 and 5 minus 1 over 4. 5 plus 1 over 4 is 3 halves. 5 minus 1 over 4 is 1. Those are your solutions. They are rational solutions, which also means this equation was factorable. And they actually show you that right here. This would have been 2x minus 3 times x minus 1. When set equal to 0, you can solve using the zero product property and get 3 halves as a solution and 1 as a solution. But of course, quadratic equation is also used for problems that are not factorable. Now they double check and show that things work, and they do indeed work out. So the quadratic formula is a substitution of values into here. What you'll often see me do, now I'll let you know, there's only one way to kind of do these problems, but this is how I would do the problems growing up. I would plug everything right in the equation straight up. When I do it with you, I'm likely going to evaluate something beforehand first, and I'll show you that shorthand once they start bringing it up more. Okay, so anyway, there's some more examples down below that we could try, but wow, we go straight to modeling with mathematics. Okay, I didn't expect that. Normally word problems are saved for the end, right? The number y of northern Rocky Mountain wolf breeding pairs, this is a jumble, x years since 1990, this is not a good sentence, can be modeled by the function y equals 0.20x squared plus 1.8x minus 3. When were there about 35 breeding pairs? So y, the number of y breeding pairs, we substitute 35 for y. So they substitute 35 for y, and the first thing they're going to do is subtract 35 and set it equal to 0. Now, I am more a fan of making my numbers whole numbers. So I would probably multiply everything by 10 myself if I did the problem. They're fine. It doesn't matter. You're going to get the same set of answers. But that's the same kind of thing where, like, if I can divide everything by 2, divide everything by 10, I like to make my a value positive. I'm going to mention that right now. If they ever have an a value negative, I'm going to go, I make it positive. A lot of reasons to talk about it, mostly because it's denominator. But try and make your a positive. This one is. Anyway, they substitute their numbers straight in right here. 0.2 for A, 1.8 for B, and negative 38 for C. Now, when we have that negative 38 in this b squared minus 4ac, we do minus negative, which becomes a plus. So 1.8 squared plus whatever this becomes multiplied, and then you get 33.64. Now, they are rounding this, well, actually 5.8 squared may be exactly 33.64, I'm not sure. But we will never round early when we do these. If they ask us to round, don't round early. Use your exact answer before you type something in, and you can see where this gets a little messy looking. But I'm imagining it's exact. I'm not really looking at this stuff. We get the numbers 10 and negative 19. They were asking for how many years since 1990 that you'll have 35 wolf breeding pairs, or what year it was. It says when we're there about. So if x equals 10 is the answer, since negative 19 is ignored, we will go ahead and say that 10 years after 1990 is the year 2000. Anyway, I'm talking about quadratic formula just as much as I'm talking about like the strategy, just as much as I was talking about this problem. Okay, just moving forward, I'm going to keep going because I hit a lot of the lecture singing to you guys. This is where I want to talk a little bit about stuff, and this is what's known as the discriminant. The discriminant is the part inside of the square roots, the radicand, b squared minus 4ac. Not the square root itself, but inside the square root. The discriminant is called as such because it discriminates against certain types of numbers. And they also kind of mention it. B squared minus 4ac must be greater than or equal to 0 to get any real solutions, because we can't take the square root of a negative number. So you'll notice down here they show the different representations, and we've solved by graphing before. We've seen when you get two real solutions versus 1 versus 0, but we're also looking at what kind of discriminant value you get as a result of it. Two real solutions occur when you have a positive discriminant. That is because you're taking the square root of a positive number. And what happens when you take the square root of a positive number is you get a number out, some number out that we can add or subtract. That's why we get two solutions. If we add something or subtract something, we're getting two different numbers out as a result. If your discriminant is 0, then there's one real solution. This is in one x-intercept. This is because the square root of 0 is 0, and adding or subtracting 0 doesn't change your value. You're just left with negative b over 2a. Hey, that makes sense that negative b over 2a is not only the axis of symmetry, the value of x on your vertex, but it's also your one solution when your vertex is on the x-axis. Go figure that the x value of the vertex, being negative b over 2a, is also the x-intercept. Okay, that seems to make sense that negative b over 2a exists there. If your discriminant's negative, you have no real solutions and no x-intercepts. That's because you're taking the square root of a negative, and we can't take the square root of a negative. We are not going to be able to evaluate that. So that's why visually we have that. So point I wanted to make before I move forward is that when I do the quadratic formula with you guys, I'm likely going to evaluate the discriminant first. I think that it saves time in doing some rewrites of other things that we don't need to write. Maybe I'm going to do it directly to begin with. But after that, I'll go into the discriminant. It also saves us from needing to write things we don't need to if we find out there are no real solutions. It lets us simplify our radicals a little bit more cleanly on the side while we're working on what's on the inside. And it helps chunk your quadratic formula a little more so. Not instead of seeing it as one big thing and singing it, we got b squared minus 4ac as part of it. We got negative b over 2a as part of it. It really breaks it apart a little better, I think. That being said, when I do this at home on my own front, I probably use this whole formula, but because I know what I'm doing with it, and I know how to speed it up myself. Okay, determining the number of real solutions. Instead of just solving straight up, they say, here's an equation, how many, not what are they, but how many real solutions would there be? If you just use the discriminant portion, you can answer that question. And it's not about what the number is as much as what sign it is. So b squared minus 4ac, b is 8, a is 1, and c is negative 3. We get 64 plus 12, which is 76. Doesn't matter that it was 76. It matters that it's a positive number. A positive number gives you two real solutions because that's what happens. We can add and subtract square root of 76. 9x squared plus 1 equals 6x. I already know where this one's going. Subtract 6x from both sides, set it equal to 0, then you're in standard form. Evaluate the discriminant with b squared minus 4ac. You do the right math, you're going to get 0 out. 0 doesn't mean 0 real solutions. 0 means one real solution. The discriminant of 0 is the thing you take the square root of. One real solution in that case. Remember, negative discriminants have no real solution. Keep that in mind. I did say it doesn't matter what the number is, it matters what the sign is. It partly matters what the number is if you wanted to find out if your problem was factorable, if it would have rational solutions. Hey, y'all, if your discriminant, if b squared minus 4ac equals a perfect square for 9, 16, 25, 36, 49, 64, 81, 100, then your set was rational. You have rational solutions. That means that this was factorable, if so. Because taking the square root of a perfect square leaves you with a rational, with a number, a whole number, even at that, and you can kind of work off that and get those answers. So, very true, very cool. All right, I'm going to move forward, finding the number of x-intercepts. That's going to be no different than finding the number of real solutions. In fact, they showed you that on the other slide. Two real solutions, 2 x-intercepts, 1 real solution, 1 x-intercept, no real solutions, no x-intercepts. Because what are intercepts and solutions are kind of one the same as far as the phrasing. X-intercepts are values of x when y equals 0. So when we have an equation here, we turn y equal to 0 and do the exact same thing. B squared minus 4ac, no change. This time, for this instance of a problem, you get a negative discriminant. This time, it doesn't matter what the number is. It just matters that it's negative. And if it's negative, no real solutions. Not until we hit a later section in the chapter when we start talking about imaginary solutions. I really don't care what the number is. We stop the problem at that point, even if we were solving. Because here we're just figuring out how many solutions there are. But if we were actually solving this equation and we got to this negative discriminant, I'd say cut everything, write no real solutions, and move on. Here's the graph of that. You can see there are no x-intercepts. It doesn't ever cross there. Okay, choosing an efficient method. Yes, I love that they have a table here. Let's go ahead and explore what this table has, shall we? And I want to see how much I agree, disagree, all that stuff. Let me even move my face, and we can talk about this. When do you solve by factoring? I'm going to go ahead and say when it's factorable. Let's see what they say. When the equation can be factored easily. Oh, I didn't notice it was an advantages, disadvantages table. The advantages of solving by factoring are when it's factorable. Now, I'm good on even doing it when it's kind of a strange big set of numbers, because if I can find the factorization, it'll always be faster for me than anything. Remember, if quadratic formula is your last resort, and it can be, quadratic formula for me is my last resort. I'm not saying I won't ever use it first. I'm saying that I can always use it. So if I can find any of these ones, probably not graphing, but if I can find any of these ones, I'm going to be kind of better off with it. Bigger numbers for quadratic formulas, also a headache. You have to do this b squared and minus 4 times a times c. The numbers still get big, and using a calculator is still going to be kind of a part of that. If the equation is not factorable, guys, you can't solve by factoring. I'm just going to say that straight up. And not factorable doesn't mean no real solutions. It can, but it doesn't guarantee it. Solving by graphing, I'm not going to say there are a lot of advantages to this when it comes to solving. Understanding what the solutions mean graphically, I think, is extremely important. We just talked about that with intercepts. Let's see what they say. Can easily see the number of solutions. I agree with that. Use when approximate solutions are sufficient. You can use it. I don't agree with using it. Can use a graphing calculator. I agree with that. May not give exact solutions, and I'm pretty big on that, right? It's not just that. I would also add that some solutions are out of window range or unreasonable to find. Some solutions out of window range. There are a lot of them, even from this textbook, where they're going like, I'll just say out of window range. You know, the answer is up at x equals 100, or whatever, sorry, y equals 100, whatever. They intersect way up there, and I can't even see it. And they gave us problems like that, and I have to change my scale to make it, or I said I have to use a different method. So I don't love solving by graphing, so to speak. It's not because I don't like graphing or anything like that. It's just that it's inefficient. You may not give exact solutions. If your answer is 1 plus or minus the square root of 2, solving by graphing wouldn't have told me that so much. Using another method would. Of course, factoring wouldn't have done it either. Solving using square roots. This is good when you have, it says the form x squared equals d. More so, it's better when you don't have a linear term. Okay, when I have an x squared term only, or a squared binomial with x inside it, isolated. I can isolate it. That'd be good. It can only be used for certain equations, and they're not being specific. If I have a linear term, this is x nay, unless I can factor a perfect square trinomial, which brings me to completing the square. You can factor that down to a perfect square trinomial by completing the square and do that. However, and they say exactly what I say, best use when a is 1 and b is even. Remember, you need to force a to be 1 if not. And if b is an even number, as a result, you have that whole divided by 2 and square it. This is my best case for using that, assuming it's not factorable. You'll always see me using this before quadratic formula. It'll be significantly faster for me. May involve difficult calculations. That especially is true if b is odd, or if a is not 1, and by factoring it down you don't get b that is that way. It can definitely involve that. It's less difficult calculations otherwise in those situations compared to quadratic formula, because the numbers get a little bit bigger. Can be used for any quadratic equation, also true for completing the square, also true for completing the square. Gives exact solutions, also true for completing the square. So I guess just last resort we say that with this. Takes time to do calculations, and I agree. It's just, at best case scenario, you're still taking time to solve it. At worst case scenario, it may be more efficient than completing the square, depending on the situation. So let's see what kind of examples they show and what they say, and let's see if I agree with them. They probably will, because the pros and cons seem to line up. You'll probably won't see me solve by graphing. I really want to see when they make that choice. Unless they're forcing it on you. Solve using any method, explain your choice of method. Part A, I would solve by completing the square. This is non-factorable. Even if you subtracted the 1 over, I got a 1x squared and there's a negative 10x. I would solve by completing the square. They solved by completing the square. So I'm just going to I'm not going to talk about how to solve it right now, guys. I'll write this part out, but we're just talking about methods. Part B, if it was factorable, I'd go for it. This is something where I'd actually have to press my luck and see if I can get this if it's factorable. it is factorable. I'm getting 2x plus 3 times x minus 8. 2x plus 3 times x minus 8. So x equals negative 3 halves, or x equals 8. They use quadratic formula. But check this out. Scrolling down, plus or minus, plus or minus, plus or minus, plus or minus. Check out these answers. 8 and negative 3 halves. Yes, this did factor into. It says the equation is not easily factorable, but it is factorable. The numbers are somewhat large, though, so check this out. With quadratic formula, you got to do negative 13 squared minus 4 times 2 times negative 24. And don't mess up. But 361 is a perfect square. Square root of that's 19, and we keep working down. But it was factorable. I am more so akin to factoring. If I can factor, I go for it. Here's the other thing, and I mentioned this before. You see the b squared minus 4ac? If I'm not sure if it's factorable, I might actually just test to see if it is by seeing if this number is a perfect square. 361 was, so it's good to go. But they use quadratic formula. That's part of this section, obviously, so maybe I use it here and there. Part C, what's x squared plus 8x plus 12? That's x plus 6 times x plus 2, so factorable. X is negative 6, negative 2. So they're going to say if it's easily factorable, you do it. So it all depends. Let me tell you a few more of these. I would x plus 12, x minus 1. I'd solve that by factoring. This one looks like solving using square roots. I can add 5 to both sides, you know, like that, and I have 9x squared equals 9, etc. I can get the x squared by itself, so that's a square root method. This looks very quadratic formula-esque. I don't believe that's factorable. And this is a is not 1, etc. So I would use quadratic formula. So let's see, factoring, square roots, quadratic formula. I'd use completing the square here. It doesn't look factorable, but if I subtract 2x over, I'm going to be pretty good on that. FSQC, looking good. Those are my methods. That's what I would do. Hey, let's start jumping to the problem set now that we are 21 minutes into this, as I was singing songs and talking about stuff. Let's do the vocabulary and core concept check. What formula can you use to solve any quadratic equation? Write the formula. Well, first of all, I'm not going to negate this, guys. You can use completing the square. Completing the square, that's not the one that they want you to say. And quadratic formula is the one they want you to say. Don't forget, guys, the quadratic formula is derived from completing the square. If you couldn't do that, then you couldn't solve using completing the square all the time. So if you can use quadratic formula all the time, you can use completing the square all the time. So here's the formula. Now keep in mind, this is coming from if ax squared plus bx plus c equals 0. This is a part that people forget. And I'm not saying you have to write this part of the formula. I'm saying you have to understand what this part comes from. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This doesn't apply to things when it's not set equal to 0. When it's not in standard form, you have to identify a, b, and c properly. That's, I think, what they want you to write. Vocab, in the quadratic formula, what is the discriminant? What is the value of the discriminant? Determine. The discriminant in the formula, it's b squared minus 4ac. The discriminant is b squared minus 4ac. It determines the number of real solutions in your equation. I'm not going to break that down. I will say it out loud. It discriminates against certain numbers. If b squared minus 4ac is positive, you have 2 real solutions. If it's 0, you have 1 real solution. If it's negative, you have no real solutions. Okay, guys, we're going to go to the problem set, and we do have a bunch of them, so I'm going to be up pretty late tonight. Let's go ahead and get started. We're going to do numbers 3 through, I think, 82. Oh, boy. Hopefully there are a lot of just discriminant questions, and I'm not saying that's faster than any other type of problem, but it might be faster than the other ones that we can do here. All right, so we are going to begin with number 3 through 8, where we write the equation in standard form, identify a, b, and c that would use to solve. So we're not actually solving here. They're getting you primed and set up for the fact that if we were to solve, what would we do? X squared equals 7x. This is not in standard form unless I subtract 7x over, and now equals 0. In this case, a is 1, b is negative 7, and c is 0. Negative 7 being the linear term, the constant term is missing. It's basically a plus 0 like that, right? So c is 0 there. That is number 3. Here's standard form. Here's the a, b, and c. Number 4. Forgot to move this over. Number 4, x squared. So none of these are in standard form to begin with, set equal to 0. Whereas the next set of problems all are, they're saying, hey, equals 0. Oh, until later. All right, number 4. X squared minus 4x equals negative 12. Let's add 12 to both sides and set that guy equal to 0. Whoopsie. Set that guy equal to 0. Like that. There's your standard form. Your A is once again 1. B is negative 4. And C is 12. Number 5. Negative 2x squared plus 1 equals 5x. Now, I'm going to give you a heads up here, and I mentioned this before. I don't like my A term being negative. It's not just this OCD thing coming from factoring, and standard form likeness and stuff. It's better if A is positive. You got to take my word for it. It's better if A is positive for the sake of your problems and for solving by factoring and completing the square. So I'm going to add 2x squared over, and I'm going to subtract 1 over. Listen, there's more than one answer to this. Meaning, if you had negative 2x squared minus, see if I subtracted 5x, minus 5x plus 1 equals 0, that's fine. You'll get the same set of answers. Or maybe you won't because you might screw it up when A is negative. And that's part of the point. I want to make A positive, and I just did. A is 2, B is 5, C is negative 1. You'll thank me later when you're not sure what to do. When we need a positive denominator and you have a plus or minus involved on top and you're making more negatives than you need to bother with. The less negatives, the better. Number 6. 3x squared. 3x plus 2 equals 4x squared. I want to keep A positive, so I'm going to subtract 3x and 2 over and get 4x squared minus 3x minus 2 equals 0. Where A is 4, B is negative 3, and C is negative 2. That's all we have to do on these, right? Write in standard form, identify. Okay. Number 7. We have multiple terms here. It looks like some will combine. We have 4 minus 3x equals negative x squared plus 3x. So I'm going to add this over, make my x squared positive. 3x, if I subtract 3x over, I'll get negative 6x, and I still got that plus 4, and this equals 0. The A is 1, B is negative 6, and C is 4. I mean, this is no different than your whole negative b over 2a stuff, like not using negative b over 2a, but just standard form, just knowing what a, b, and c are. It's no different. Only these are not y equals equations, right? These are equals 0. We make them equal to 0 equations. Negative 8x minus 1 equals 3x squared plus 2. I like my x squared term positive, so let's add 8x over, so it's plus 8x. Let's add 1 over, and 2 plus 1 is 3, and that equals 0. So there's the standard form equation. Your A is 3, B is 8, and C is 3. Okay, we're going to be doing that same thing and identifying them when it comes to solving, and it looks like we will begin solving. Hey y'all, quadratic formula, a lot of problems to do with these, and this is just the cream of the crop. We'll see what else we have to do ultimately. Hopefully a lot of discriminant questions. 9 through 22, solve using the quadratic formula, round your solutions to the nearest tenth if necessary. I'll have my calculator ready, but I will be writing exact answers first before we move forward. Now, this problem is factorable. I can already tell you this answer is going to be x equals 6. That being said, your formula comes from using A, B, and C. A, B, and C. For the first two problems, guys, I'm going to plug it straight into here, where this is standard form set equal to 0. We're going to say x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. You can already see the time-consuming step in just writing all of that. Opposite of negative 12 is positive 12. Plus or minus the square root of negative 12 squared is 144. Minus 4 times 36. 4 times 36, 144. All divided by 2. 2 times 1. Now the square root of 144 minus 144 is 0. We're adding or subtracting the square root of 0, which means we're doing 12 plus or minus 0. And you can see 12 plus or minus 0 is still just 12, just one number, and 12 divided by 2. So x equals 6. There's only one answer to this, and x equals 6. Rounded to the nearest tenth is 6.0. Now, how did I know that from the jump? Because this is a perfect square trinomial that factors to x minus 6 quantity squared. So if you could solve by factoring, I totally would. Much better method, but we're starting with some clean numbers here. So you can see all the writing that's involved, and maybe I did some cleanup faster, maybe some slower. If you know how to cut corners, go ahead and do so. My cutting corners will come from writing the discriminant out first. I won't guarantee that gives you less writing, but I think there's less redundancy when you do so. So let me do at least one more problem with you this way, exactly how I did the last one. Then I'm going to probably start with the discriminant first, especially when we start seeing no real solution answers. Okay, so your A value is 1, B is 7, C is 16, and we're going to be doing x equals negative b plus or minus the square root of b squared minus 4ac over 2a. This is an example of when I would have loved to have done the discriminant first. This is x equals negative 7 plus or minus the square root of, this is 49 minus 16 all over 2. Excuse me, 16, 64. 64 all over 2. And this is x equals negative 7 plus or minus the square root of 49 minus 64 is negative 15. So negative 15 all over 2. You can't take the square root of negative 15. There's no version of simplifying this for real solution's sake. Once you hit this negative inside of here, we start to say no real solutions. This is the answer. So like I said, I did more than I feel like I needed to. If I just went to evaluate the discriminant immediately, I would have gotten that negative 15 and said nothing else to have to plug in, write out, or come up with. From there, I would have been able to establish that. So here, we did. It took a little bit more time, though. So now I'm going to start doing it that way. This one looks factorable again on number 11, so it looks like we'll have some rational solutions. Let's go ahead and solve x squared minus 10x minus 11 equals 0. Quadratic formula would be a is 1, b is negative 10, c is negative 11. And let's start with the discriminant. I'm going to write disc for discriminant. If you ever see me do that on a video, that's fine. If I just write D, you'll understand. We're going to start with just b squared minus 4ac. b squared minus 4ac. I think it gets you to focus on this part a little bit more. That's 100 plus 44, which is 144. 144 is a perfect square of 12. So here's what I'm going to do, right? Square root of 144 is 12. This is that square root of b squared minus 4ac part. So here's your formula. X equals negative b plus or minus the square root of b squared minus 4ac, boom, all over 2a. Now, what would have made this even faster is the opposite of negative 10 is 10, and plus or minus 12 all over 2. This is where I'm going to probably write it next time and go negative b, the opposite of negative 10, plus or minus the square root of b squared minus 4ac, all over 2a. And listen, when a is 1, I'm doubling any number's pretty straightforward, right? But doubling 1 is even easier. It's just 2. A lot of times, guys, you're just going to divide all by 2. It's just going to happen. So x equals 10 plus 12 over 2, which is 22 over 2, which is 11. Or x equals 10 minus 12 over 2, which is negative 2 over 2, or negative 1. So those are the two different answers that we get there. Like I said, it was factorable, and that's what we got. All right, let's go to number 12. This is where speeding up would be quite encouraged. I think this is factorable as well. It looks such, at least. Also in standard form, set equal to 0. A is 2, B is negative 1, C is negative 1. So your discriminant, let's do b squared minus 4ac, which is going to be 1 plus 8, which is 9. And the square root of 9 is 3. So let's see if we can kind of do this together in kind of this more mental way. X equals minus b, so the opposite of negative 1, right? Minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So there's a lot faster approach to doing this, and I feel that this is a lot less written than like that. Which, it's not too much, but just a lot less written than that, or the one before on number 9, right? I feel like I was doing a lot more here and just computing within while this was waiting. These were just waiting for you to do more, and I'm making that happen. I feel like I'm writing a lot less in this format here. Opposite of negative 1 is 1. The square root of 9 is 3. 2 times 2 is 4. Now 1 plus 3 over 4 1 plus 3 is 4, divided by 4 is 1. 1 minus 3 is negative 2, divided by 4 is negative 1/2. Once again, rational solutions because this was actually factorable. Number 13, 2x squared minus 6x plus 5 equals 0. So, once again, you're kind of, if you're watching this video, I wouldn't say you're victim to or subject. Yeah, sure, yeah, you're subject to the way that I'm solving these method-wise, right? So, choose to, choose not to. You can solve on your own. Pause, fast forward, see if you get the same answer. But I'm going for strategies that I think works best for me. Standard form set equal to 0. Let's go straight to that discriminant, which is b squared minus 4ac, or 36 minus 40, which is negative 4. No real solutions. I didn't solve for x. I found out how many solutions there would be. The discriminant is negative. When the discriminant is negative, we'll have no real solutions. I'm not going for the whole quadratic formula. B squared minus 4ac told me everything that I needed to know. Number 14 looks a lot like, did we just have a problem with it? Maybe it was in the examples. Number 14, this will have one real solution. Oh, it's going to be a fraction. But this is going to be 9x squared minus 6x plus 1 equals 0. So let's start with the discriminant. Maybe we'll just start writing d there. So b squared minus 4ac. This is 36 minus 36, which is 0. Discriminant of 0 just means one solution. I have nothing to add or subtract. Plus or minus square root of 0 is just the thing. You know what x is? Honestly, it's just negative b over 2a. Negative b, opposite of negative 6 is 6, over 2a. 2 times 19 is 18. If I'm going too fast, we'll pause it for a second, but think about what we just did. What did I just do here? Negative b over 2a. How come? Because we're adding or subtracting nothing. The discriminant 0. So negative b plus or minus the square root of b squared minus 4ac, 0. Nothing's there. All divided by 2a? Well, just negative b over 2a. Same thing as axis of symmetry talk, right? Opposite of negative 6 over 2 times 9. 6 over 18 is 1/3. It's one single answer because the vertex is on the x-axis. So some steps skip writing if I feel like we know how to take the opposite of a sign and we know how to double a number. So I'm going to continue doing that. I say I'm going to continue doing that. I legit am at this point, right? There's a speed. There's a time constraint for me when it comes to doing like 3 hours worth of problems, and that's where I'm going to do it. I can add 6 to both sides, and I, in fact, will. This is just like the very first problems where they said identify A, B, and C by setting it equal to 0, and that's what we're going to do. So we begin with that. Let's start with the discriminant now. Okay, I'll just write D. Apparently my fingers are just going to write D, so I'm going to do that. Let's start with B squared minus 4AC, which is 169 minus 36 times 4 is 144, which is 25. Okay, that means this was factorable. I didn't explore that, but that makes it factorable. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All over 2a. So 13 plus 5 is 18, and 13 minus 5 is 8. 18 over 12 is 3/2. 8 over 12 is 2/3. That must mean this must have been factorable to 2x minus 3 times 3x minus 2. I didn't bother exploring it, like I said, but negative 4 minus 9 is negative 13. That seems to work out. So that's what it was factorable to, but those are your two answers. Kind of a fun appearance of answers. Number 16, negative 3x squared plus 6x equals 4. Okay, I am going to go by my own version of what I want to do, which is turn my A positive. Now, I can either add this and subtract this over, or I can switch all the signs ultimately. So I could also do this. I could subtract 4 over, and then I can, divide everything by negative 1, however you want to put it. When you divide 0 by negative 1, you still get 0, so that doesn't change anything. Writing this and writing this, same thing. It's not the same graph. One's upside down, one's right side up, but it's the same solutions. It's the same values of x that'll work if there are any solutions, of course. So discriminant is where we'll begin, and we're going to start with b squared minus 4ac. So that is 36 minus, 36 minus 16 times 3 is 48. Uh-oh. Minus 48, which is negative 12. This is no real solutions. And that has nothing to do with the fact that I turned everything positive, or that I changed all the signs, or that A started out negative. It just has to do with the size of the numbers and the signs that they are. If C was negative, boom, we'd have real solutions, just because the way that this thing's graphed is just a different looking graph that way. So this is negative 12. No real solutions. That was your discriminant. Number 17. I see a perfect square I'm smelling a perfect square trinomial on number 17. It's just the appearance of the numbers. The hey, appearance of numbers. 1 minus 8x equals negative 16x squared. I will add 16x squared to both sides. I will put the negative 8x next, and plus 1 equals 0. The discriminant is going to give us probably 0. B squared minus 4ac, which is 64 minus 64, which is indeed 0. So your x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, 2 times 16. That is 1/4. One solution, one real solution, as we had a 0 discriminant. Number 18, non-factorable. I would use quadratic formula for this problem. I wouldn't bother with completing the square because that 5 was an odd number. But this is in standard form set equal to 0. Let's use standard form. Let's use quadratic formula. Discriminant b squared minus 4ac gives us 25 minus 12, which is 13. So this is the first set of something that, to my knowledge, I think the other ones were either no real solution or factorable. This is the first irrational solution set. The square root of 13, well, it can't be simplified, but it's also not a perfect square. So when we start solving this, we're going to say x equals negative b, the opposite of negative 5, plus or minus the square root of b squared minus 4ac, all over 2a. 2 times 1 is just 2. Now, this is the exact set of answers. And we've talked about this kind of thing before, right? This is the exact set of answers, 5 plus or minus root 13 over 2. I'm going to use the calculator and round this, and I mentioned this in 4.4, how you got to use parentheses on top. I'm not showing you my set. I'm just going to go ahead and type it up. I assume you continue this video series from 4.4 and you followed some of the things that I mentioned when it comes to calculating. But they say to the nearest tenth this time. Is that what they said? Nearest tenth, so 1 decimal place. So 4.3-ish is going to be one of the values. And then, whoops, let me, sorry about this. And then 0.697, so about 0.7 is the other solution there. Those are the x-intercepts, where they cross the x-axis. The vertex is at 5 over 2, right? Negative b over 2a. And then these are the equidistant from there. All right, number 19. We're still in this first block of problems here. That's why speed is of the essence for me. I'm doing 82 problems. X squared plus 2x equals 9. Ooh, I would love to solve this by completing the square. I think I'll show you the completing the square solution set after this. But let's set this equal to 0. Remember, if it's not equal to 0, then that's not your true z. Your c value isn't 9, it's negative 9. You have to remember that. Discriminant is going to be b squared minus 4ac. And see, here's the difference. When c is negative 9, we end up adding 4 plus 36, which is 40. Now, 40 is the thing that goes inside the square root. If you want to start doing some simplifying radicals now, root 40 is root 4 times root 10, or 2 root 10. This is the square root of b squared minus 4ac, right? 40 is just b squared minus 4ac. This is the square root of b squared minus 4ac. So x equals negative b plus or minus the square root of b squared minus 4ac. Boom. All over 2a, 2 times 1. So this would be the correct answer, just like this one was. However, I can divide 2 and 2 by 2. I can divide everything here by 2, and if you can, we go ahead and do that. We turn these into 1s. Remember, they are both dividing by 2 as their separate terms. The root 10 doesn't, and even if it could, we already divided a portion of it by 2. So instead we say negative 1 plus or minus the square root of 10. It's divided by 1, so we can just write it like that. That was solving using the quadratic formula. I know this isn't the method of, or this isn't the section where they say choose which method to solve, but let me show you solving by completing the square here, and just where I feel that this was a cleaner set of stuff. First of all, the original problem said this, equals 9. From here straight up, I can complete the square by adding the number that goes here and here. 2 divided by 2 is 1, 1 squared is 1, and we add that. This factors into x plus 1 quantity squared. X plus 1 quantity squared, and 9 plus 1 is 10. When you take the square root of both sides, we get x plus 1 is plus or minus 10, or root 10. Subtract 1, x is negative 1 plus or minus root 10. So not only did I get, obviously, the same answer, not only did I get the same answer, significantly less, guys, look at this, significantly less steps. Didn't have to simplify a radical, didn't have to reduce a fraction. Didn't even have to get it in standard form over here. That was just the nature of the way the problem was written. But don't tell me that completing the square isn't more efficient in this situation. Significantly less work. Didn't have to simplify a radical, or at least not as big of a radical if I did. Didn't have to reduce a fraction or seek fraction reduction. If you learn completing the square, guys, there is benefit to it. But I really also wanted to show you that completing the square and quadratic formula would get you the same answer. And furthermore, why we had to simplify this radical and reduce this fraction. I wouldn't be able to reduce the fraction if I didn't simplify the radical, and if I didn't reduce the fraction, I wouldn't get the same matching answer. Oh, I didn't round these yet. Let me go back. Well, excuse me. Let's do negative 1 plus root 10. Which is about 2.2. And I'm assuming negative 1 minus root 10 then would be about negative 4.2. I'm just going to go ahead and write that. If I'm wrong, sorry. But negative 4.2. I don't think it's wrong. Okay, so there was quadratic formula completing the square for number 19. I'm only going to do quadratic formula here on out. I just wanted to show that. And I would not dare do completing the square on this problem. Anyway, we good. Quadratic formula, you win on this one. Number 20, 5x squared minus 2 equals 4x. Let's subtract 4x over. 5x squared minus 4x minus 2 equals 0. Excuse me. The discriminant will be b squared minus 4ac, which is 16 plus 40, which is 56. 56 is a perfect square. Excuse me, it's not a perfect square. 56 has a perfect square factor because you can do 14 times 4, which is 2 root 14. So x equals negative b, 4, plus or minus the square root of 56, which is 2 root 14. I hope I did that right. I think I did. All divided by 2 times 5, which is 10. So these can all divide by 2, same thing as before. We want to make everything half the size that it was before. 5, 1, and 2. So now this will say x equals 2 plus or minus the square root of 14 all over 5. There's that version of the answer. By completing the square, you get the same thing, but I would not dare complete the square on that for a bunch of reasons. The 5 is the reason I wouldn't on that one. Quadratic formula, you won. Perfect time to use it. It's a little bit of work, but I wouldn't have it any other way. Let's evaluate what that is. 2 plus square root of 14 divided by 5. It's late. Divided by 5. It's around 1.1. I don't know why they have me round. It's not a word problem. And then 2 minus root 14 all divided by 5. Negative 0.3. Okay. All right, number 21. Still on this section. 2x squared plus 9x plus 7 equals 3. Quadratic formula wins. 2x squared plus 9x plus 7 equals 3. Let's subtract 3 from both sides of this equation. 2x squared plus 9x plus 4 equals 0. This is factorable. I take it back. This is factorable. Factoring would have won. We're going to get x equals negative 4 and x equals negative 1/2. So let's go ahead and use quadratic formula though. Well, hold on. I'm going to do this by factoring first. Let's go to this. 2x like that. This is 8x plus 1x is 9x. So x is negative 1/2, x is negative 4. If I can factor, and I can factor faster than I can use quadratic formula, if I can factor, I'm going to go for it. They call it not easily factorable. Depends on how good your factoring strategies are. Discriminant is b squared minus 4ac, which is 81 minus 16, 32, which is 49. So x equals negative b, so negative 9, plus or minus the square root of 49, 7, all over 2 times 2, 4. X is negative 9 plus 7 over 4, which is negative 2 over 4, or negative 1/2. Or x is negative 9 minus 7 over 4, or negative 16 over 4, which is negative 4. Same answers as up there. 2 steps, a lot less work than what we had to do there. Now, both of them had to get this in standard form set equal to 0. So that didn't change. Yeah, that absolutely did not change on that. Excuse me. Number 22. So instead of sniffles, you're going to get yawns this time. What's funny is I'm not bored. I'm engaged. 8x squared plus 8 equals 6 minus 9x. Okay, add 9x over, we get 8x squared plus 9x. Subtract 6 over, you get plus 2 equals 0. Not factorable to my knowledge. It doesn't seem factorable. I'm just going to go ahead and go to quadratic formula. Discriminant is b squared minus 4ac, which is 81 minus 3264, right? Yeah, 64, which is 27. So yes, not factorable. Not a perfect square, so not factorable. Square root of 27 is root 9 times root 3, or 3 root 3. For quadratic formula, x equals negative b, plus or minus the square root of b squared minus 4ac, all over 2a. 2 times 8 is 16. None of these can we can't reduce this. 9 and 3 can't divide by 16 at all. Now, both would have to for us to do the actual reduction. So we're going to leave it like that. I mean, I'm going to round to the nearest tenth, but we're going to leave the exact answer like that. So negative 9 plus 3 root 3 divided by 16, and negative 9, whoops, I just hit some wrong button here, divided by 16, and then negative 9 minus 3 root 3 divided by 16. I'm getting negative 0.2 and negative 0.9 about. We're rounding to the nearest tenth, so negative 0.2 and negative 0.9-ish. Ish. All right, that's the end of that set. Let's go down to modeling with mathematics in number 23. A dolphin jumps out of the water as shown in the diagram. The function h, let's see, 23. The function h equals negative 16t squared plus 26t. Models the height h in feet of the dolphin after t seconds. After how many seconds is the dolphin at a height of 5 feet? So we're going to set 5 equal to this thing right here. Set everything equal to 0. Whether I want to solve, even if it was factorable, I'd want to do this. 16t squared I'm going to add over. 26t I'm going to subtract over. I got 5 positive on that same side, and that equals 0. If it's factorable, you got me. Doesn't look factorable. Looks close, actually. If this was a negative 24t, that would be factorable. Wait. No, it wouldn't. No, it wouldn't. Not factorable. Okay, let's go to quadratic formula. That's the next place we go. Let's start the discriminant. Discriminant is b squared. I don't know 26 squared. This is why I wish it was factorable. Minus 4ac. 26 squared. Let's get the calculator. 26 squared. 676. 676 minus 320. Yeah. Which is 300. I'm terrible with subtraction. 356. Not a perfect square, so not factorable. 356. I don't know what it can divide by though either. It can divide by, can't divide by 9. Can't divide by 16. Well, let's first divide it by 4. It can divide by 4, and you get 89. 89, not 89, I think, is a prime number as well. So square root of 356, y'all, is root 4 times root 89, which is 2 root 89. Now, because it's a word problem, I'm probably not as worried about this exact answer. We want to get an answer that this time we're going to round, and I'm totally okay with that. I do prefer it. But here it's going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A being 16, so 32. So what is this saying? After how many seconds is the dolphin at a height of 5 feet? If I did 26 minus 2 root 89, I'm probably looking at one of those, well, the square root, that's, no, there's more than one answer. There's more than one answer when it comes up and when it comes down. So there are going to be 2 answers here. Yeah, it's not negative. So we're going to be doing 26 plus 2 root 89 all over 32. I just put 31. That's not going to help. So 1.40 seconds, I'll put. And also minus, the 1.40 is probably the bigger one. So minus is 0.222, so 0.22 seconds. Obviously the first one, this is when the dolphin was coming up and out of the water. This is when the dolphin was coming back down into the water. Pretty high jump. All right, that's number 23. Number 24, also modeling with mathematics. I probably need a new page for this one. So number 24, the amount of trout, Y in tons, caught in a lake from 1995 to 2014 can be modeled by this equation here. So I got Y equals negative 0.08x squared plus 1.6x plus 10, where x is the number of years since 1995. When were about 15 tons of trout caught in the lake? So we're going to substitute 15 for y and then solve for x here. Quadratic formulas, the way that they're kind of encouraging. I'm going to add the 0.08x squared over here, subtract the 1.6x, and subtract the 10. And we get plus 5 there equals 0. Now, I kind of mentioned this before, but I really like my numbers being whole. You can plug them in like this. It's all up to you. Just work the calculator how you like. If I multiply everything by 100, I get this. But I can even work on reducing that. I can divide everything by 8, and I get x squared minus 20x plus, no, 8 doesn't go into, 8 doesn't, I can't do 8. I can divide everything by 4. I get 2x squared minus 40x plus 125 equals 0. All right, so assuming all my math worked out right, I'd just rather deal with these numbers. I know they're going to get bigger consequently. I just don't want to work with decimals if I don't have to. So the discriminant is going to be b squared minus 4ac. So now I can do some of this stuff in my head. So this is 1600 minus 1000, which is 600. So 600. Now keep in mind, this is one of those. This is the time I'm not this. I mean, this is 10 root 6. Square root of 600 is 10 root 6. But I don't even care about that. We can work with the square root of 600 and we'd be good. That being said, since I got it, I'll just go ahead and write it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which is 4. Now, let me go back to the previous problem really fast here. Could that fraction reduce? I could have totally reduced this fraction, y'all. I feel like I'm obligated to work out some things that if I can reduce it, I will. The answer's still going to be the same, but I could divide everything here by 2 and get x equals, I'll go back, don't worry, x equals 13 plus or minus root 89 over 16. Right, so this gives you the same answer set, I imagine, if I did everything right there. So same thing here. Everything on this problem can divide by 2 as well. So if we divide everything here by 2, then we're going to get x equals, which is, I'm overdoing the work, right? Our goal is really to answer the question, when we're about 15 tons of trout caught in the lake. I don't know if there's more than one answer here. I don't know if the square root of 600, yeah, that's less than 40. So yeah, there are gonna be two answers here. Let's do, I'm gonna do 20 plus 5 root 6 all over 2. And we get 16.1, so about 16. So x is about 16. And also 20 minus this. Now what we got to check is what domain we're referring to. So about 4. X is about 4 there. Okay, so what are we doing with this information? Where the X is the number of years since 1995, and it goes from 1995 to 2014. So let's do 1995 plus 4 and 1995. That's wrong. 1995 plus 16. Both of these are years when there were about 15 tons of trout. So in the year 1999, remember that's a year, and 2011, which falls within the range, the domain from 95 to 2014. Do you think this model can be used to determine the amounts of trout caught in future years? Explain your reasoning. Well, probably not. Remember that this model was a y equals setup, and this thing is an upside down parabola. So maybe it does to an extent. This might apply. This might apply to an extent. However, eventually the parabola, the upside down parabola, parabolic model, will start representing negative trout amounts to the point that the model is rendered useless. So remember, an upside down parabola goes down forever as long as you let it. So if it keeps going down forever, then eventually it'll hit some negative values, and that's not what we're trying to look for there. So that's not 25. I'm sorry. That's part B. So this is part B on that thing. So yeah, eventually, not really. And that's the thing with models. They only apply for so long. Okay, numbers 25 to 30 determine the number of real solutions to the equation. So we've been doing a lot of this with the discriminant. Maybe I really leaked it early with this, but we're not going to solve the entire thing. We still need to set it equal to 0 if it's not, and still use the discriminant portion. Once I find the discriminant, and I don't care what the value is. I only care what the sign is. Unless the value is 0, I care. So for the discriminant here, we're going to do b squared minus 4ac, which is 36 minus 40, which is negative 4. Doesn't matter what the number was, it's negative. You have no real solutions. Once you find the discriminant sign, you're good to go. This is where you're likely to get some 0 discriminants. Number 26, I can tell you already there's going to be 2 real solutions. I'll tell you why in a moment. There are other ways you can figure it out, actually, too. Not always, but there are other ways that you can kind of work it out. And this is kind of what we want to talk about here, right? We're going to talk about all things that work out. B squared minus 4ac is 25. Negative times negative is positive, so plus 12, which is 37. Now, 2 real solutions. So, a couple reasons why I knew that this was going to be, and it has everything to do with c being negative, and of course a being positive, but let's talk about that. You see, if a is positive and c is negative, what does c represent in our graph? If we graph this, c would represent the y-intercept at negative 3. We have a point that's underneath the x-axis for a parabola that is facing upward. If a is positive, the parabola faces upward. So if I'm underneath, it needs to hit, I don't know if this is the look of the graph, but it needs to hit twice. It needs to hit twice. The graph is underneath. That's one way to say that graphically, this can help explain how I know there are 2 real solutions. Even the discriminant. How is the discriminant ever going to be negative? See, when I square a number, it's going to turn positive, and when I add a number, it's going to stay positive. How do I know it's going to add? Because the formula has a minus, and we are multiplying by a negative. So negative times a negative to get a positive. So from here, it's positive and a plus. It'll also do that as well. So there are some ways that you can give it away, and that's not always the case, right? This first one was undetermined. You can have a positive y-intercept be a positive graph, and just like this, you could also just miss the x-axis just like that. Oh, just missed. Or you could hit it. Who knows? It can just miss, just hit. Not really sure. That's where you got to do the test. How different are those A, B, and C such that it actually will hit the x-axis or not? That's what we're dealing with. 2x squared minus 12x equals negative 18. Okay, this problem is somewhat a first of its kind here, where I'm going to add 18 to both sides, but furthermore, when it comes to this, guys, I do not have to use numbers this big. I kind of manipulated a decimal problem into doing something like this, but I'm going to divide everything by 2 and get x squared minus 6x plus 9 equals 0. And you know what? I see that this is going to have one solution because it's a perfect square trinomial. I didn't see that before, but now I do. Anyway, the discriminant is going to be b squared minus 4ac, which is 36 minus 36, which is 0. A 0 discriminant means one real solution. The solution isn't 0. In fact, the solution is 3. But the discriminant of 0 means there's only going to be one answer. All right, number 28 looks also like a perfect square trinomial. In the works. Number 28, we have 4x squared equals 4x minus 1. Let's subtract 4x to both sides. Let's add 1 to both sides. And I was going to say let's factor. Let's evaluate the discriminant as b squared minus 4ac. That's 16 minus 16, which is 0. Once again, one real solution. That solution is 1/2. Solving by factoring would get you that. Number 29. So we got a fraction, and the a value is also negative. Not a fan. I'm going to go ahead and deal with that personally because I can. I could do that early on, but I'm going to add 2 to both sides. Now I'm going to multiply everything by negative 4. Make everything negative 4 times bigger. Turn this into x squared minus 16x minus 8. Not factorable. But let's go for that discriminant. The discriminant is now going to be b squared. And now, you know what? This a actually was going to be pretty nice because when you do b squared minus 4ac, 4 times 1/4 would have been 1. So actually, that would have been probably better. Sorry. If we were doing the whole quadratic formula, I don't want to do divided by 2a and 2 times negative 1/4 though. So it's one way or the other. Minus 4ac, which is 256 plus 32, which is a positive number. I don't care what it is. It's 288. It's a positive number. 2 real solutions. Now, since I multiplied everything by negative 4, I did indeed make my discriminant bigger, but of course it would make every number bigger, including the denominator of the fraction. So my solutions would have been the same. The discriminant is just a much larger number, but it also still would have stayed positive. The fact that I multiplied by bigger numbers or negatives shouldn't change the fact that the discriminant will be positive. It may be a different number, but you still have 2 real solutions. And then number 30, we have negative 5x squared plus 8x equals 9. 9. I'm going to add 5x squared over and subtract 8x over and get 5x squared minus 8x plus 9 equals 0. And I don't see that as factorable. Not that I'm trying to, but I don't believe it's factorable. So discriminant is b squared minus 4 a c. Oh, it's not only not factorable. 64 minus 180. Listen, I don't care what it is. It's negative. Negative. I mean, I can figure it out as I talk to you, but no real solutions. Did they say? See, they didn't say evaluate the discriminant. That's obviously what we're doing to get the answer. Whatever it is, I don't care what it is. Negative. No real solutions, right? So that's the thing. All right. Find the number of x-intercepts in the graph of the function. Okay, so this is going to be akin to what we just did. I'm still working with discriminants. The one different, they're just training you on making sure that you know what something means interchangeably and how you work off of it. The difference here is this says y equals, but finding x-intercepts are finding the values of x when y equals 0. So x squared plus 5x minus 1 equals 0. Same stuff. Discriminant, b squared minus 4ac. is 25 plus 4, which is positive, which means 2 real solutions. That's how I wrote that. I don't know why. Number 32, 1 real solution. Number 32, 4x squared, y equals 4x squared plus 4x plus 1. Let's set that equal to 0. Let's use our ABC for our discriminant, b squared minus 4ac, which is 16 minus 16, which is 0. There's 1 real solution. I'm going to go ahead and write it like that from now on. Number 33. What was I going to mention to you guys? I was going to say something. Now I don't know. Oh, I was just going to say that, the quadratic formula, as big as it probably felt before, what are the 2 big chunks of the quadratic formula at this point that you notice? The discriminant, b squared minus 4ac. Obviously, it's inside of a square root. There's a plus or minus. I get all that. But it's inside of a square root. And there's the negative b over 2a concept. Now, the whole thing's being all divided by 2a. But if you get those chunks out of it, then you're well on your way of but getting that quadratic formula. It's a big formula with 2 big chunks that we practiced this one so much. Negative b over 2a was so ingrained that hopefully we can get them in. Anyway, change all the signs. I like my a being positive. It's just an OCD thing. I just want to get used to it for when we have to do it on another problem. So we got b squared minus 4ac, which is not going to be a positive number. 9 minus 96, no real solutions. No real solutions. Number 34. Y equals negative x squared plus 5x plus 13. Let's set this guy equal to 0. And then let's divide everything by negative 1 because reasons. Now I can tell you there will be 2 real solutions. I mentioned this before. Negative y-intercept, positive stretch factor. But I don't know. I mean, should we keep going? That's the thing. Is at that point, what are we asking about? Because they are not asking us about the discriminant. They said find the number of x-intercepts. So there are ways to do that. And not always, but 25 plus, right? 25 plus something. See, I'm taking time to think about it. 52, so 77. 2 real solutions. I think, these are only the last 2 questions while we're doing it, but here on out, if I run into something that's obvious like that, I'll tell you. And by the way, that was after I changed the equation. Here's what the original one was. A negative, which means upside down, and a positive y-intercept. So the same thing. Crossing from up above and going upside down is going to hit the x-axis twice. Maybe that's what they actually wanted me to do instead of discriminants. Not really. Number 35. So we're talking more of the same here. How do you feel that we can just talk about this part? No discriminant conversation. I got a positive, right side up facing graph with a negative y-intercept. This will also be 2 real solutions right there. Excuse me, these aren't real solutions. This is the number of x-intercepts. I should really go back on these ones. So determine the number of x-intercepts. This was number 31. Sorry about that. Let's just go ahead and change all those really fast. 2 x-intercepts. Number 32, 1 x-intercept on the vertex. 0 x-intercepts. Two x-intercepts. So yeah, they cross the x-axis twice. Again, discriminant would have been b squared and then a plus because minus and negative there. So 2 x-intercepts. And number 36, this one is, you have to test it. I know there will be one, but you have to test it here. Where we have f of x, because we have a positive y-intercept and a positive stretch factor. So who knows? Maybe it goes down low enough to reach. It just so happens to reach just close enough here. As we divide everything by 2, we get x squared plus 4x plus 4 equals 0. So the discriminant will be b squared minus 4ac, which is 16 minus 16. We've seen that kind of thing before. Different equation, which is 0. That means 1 x-intercept. They have to make sure they throw in a couple of those. I just wish they diversified it a little bit more. All right, solve the equation using any method. Explain your choice of method. Great. This is where I get to have a little more fun with myself. I don't have to use, or I'm not required to use quadratic formula, but I will use it at last resort, and it will be plainly obvious. It's not factorable. There's an x term instead of just the x squared term, and it's not just a 1x squared with an even linear coefficient after factoring. So number 37, negative 10x squared plus 13x equals 4. I'm going to get 4 to the side by subtracting it. I'm going to, change my signs here, even if I use quadratic formula. We'll see. And I want to first see if this is factorable. That's going to be just kind of my first go-to here. So can I factor 5x and 2x with some form of this thing of negatives? No, that's not going to get me anywhere for that. Not factorable. Given everything else, this is quadratic formula. It's just I'm just going to say last resort. Last resort. All I mean by this is unfactorable. I don't have a 1x squared for completing the square, and there is an x term not using square roots. Notice I'm not going to solve any of these by graphing. I have no intent to early on, at least. I want to let you know that. Anyway, so let's start with the discriminant. We're going to get b squared minus 4ac. By the way, there might be no solution. Which is 169 minus 16 times 10. No, oh, this is factorable. Oh my goodness, I missed it. 5222. Oh, 4 and 1. This was factorable. And see, this is where this test works. This is where this helps me. Discriminant, I'm going to stop there, and now I'm going to factor it. Now they know this is a perfect square. Let's go back to factoring. I forgot about 4 and 1. I was so intent on minus 4 and 1. Here we go. Negative 5 minus 8 is negative 13. Ah, darn it. Not a last resort. It is factorable. So, but that's what the book said, right? They said if it's not easily but factorable. So factoring, because I could. I stopped at 2 and 2, and I never should have used 2 and 2 anyway. I underthought it. All right. X equals 4/5 or x equals 1/2. Listen. Even just doing the discriminant, I still would have had not much more work to go. 13 plus or minus 9 all over 20. I like factoring when I can use it, and I wish I could rewind time and say that this was factorable and go after that. My bad. Number 38, x squared minus 3x minus 40 equals 0. I can tell you this is factorable. This factors, I'm going to use factoring because easily factorable. This is x minus 8 times x plus 5. This means x equals 8 or x equals negative 5. All right. Number 39, x squared plus 6x equals 5. This is not factorable. This is... Oh, and I have to pause because my throat, hold on. Okay, sniffles always seem to come after a sneeze, so be prepared. X squared plus 6x equals 5. This is very completing the square, CTS. You have a quadratic coefficient of 1, even linear coefficient, and 5's already on the other side of the equation. Perfect. Let's complete the square here. Oh, and I was going to say, this is non-factorable. So here, we're going to add 9. 6 divided by 2 is 3. 3 squared is 9. Add 9 to both sides. This factors to x plus 3 quantity squared. 5 plus 9 is 14. Take the square root of both sides. X plus 3 is plus or minus the square root of 14. And subtract 3 from both sides. X is negative 3 plus or minus root 14. They don't ask us to round to the nearest hundredth or tenth or anything like that. I'm done. I don't have to keep going on the calculator. All right, number 40, negative 5x squared equals negative 25. This is where I'm going to solve using square roots. I don't have an x term, so I can get my x squared term by itself by dividing by negative 5. And that leaves me, so this is square root. That leaves me with being able to take the square root of both sides. X is plus or minus the square root of 5. By the way, you can solve this using quadratic formula, right? If I said x squared minus 5 equals 0, a would be 1, b would be 0, and c would be negative 5, and you could still do that. Take more time, obviously, because I'm done now, but you could solve using quadratic formula. Can't really solve using completing the square because there's no b term to work off of. 0 divided by 2 is 0, squared is 0. So completing the square doesn't really apply. You can, but it doesn't really apply to that kind of problem. I already have a perfect square. It's just not a trinomial. X squared plus x minus 12 equals 0. This is factorable. So I'm going to factor. So this factors into x plus 4 times x minus 3. Where we get x is negative 4 and 3. They would recommend that for you too. That first one, they would recommend quadratic formula. They say it's not easily factorable. Clearly, by me not factoring to begin with kind of indicates that. That was my mistake thing I just gave up early. All right, number 42, x squared minus 4x plus 1 equals 0. This is not factorable. I will use completing the square. I do have an even linear coefficient with a 1x squared. I first must subtract 1 from both sides. And now I'm going to add something new. I say, excuse me, 1. I need a new number, which is 4. Negative 4 divided by 2 squared. So we get that. This factors 2x minus 2 quantity squared. And negative 1 plus 4 is 3. We take the square root of both sides. We get x minus 2 is plus or minus the square root of 3. We add this 2 over to both sides. We get x is 2 plus or minus the square root of 3. Those are my two answers. Completing the square was cool, man. Completing the square is cool. Not always, but there, it was cool. Smelling quadratic formula. Number 43. Let's bring it. We haven't done quadratic formula yet for these, have we? I started one, and once I got to that discriminant, I said, oh, it's a perfect square trinomial. Excuse me, it's a perfect square discriminant. So quadratic formula, last resort, baby. Not factorable, and you can bank on that. A 4x squared, all that jazz. Let's begin with that discriminant where we get b squared minus 4ac, which is 1 plus 16 times 17 is 272, which equals 273. I have no reason. Oh, you can divide that by 3, but 3 is not a perfect square. I was saying this might be prime. 3 and 91. So 91 is prime. So we got nothing. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. 2 times 4 is 8. That's the answer. If you can't simplify the radical, you're done, right? That's it. And yeah, we're finished with that. Number 44, x squared plus 6x plus 9 equals 16. Okay, this one's interesting. So, I'm going to solve using square roots. Now, this goes against what I said about solving. Well, sort of. I said, you can't solve using square roots if you have an x term available. I said, unless your thing is already a perfect square trinomial. Now, the other way I would have solved was using the, well, this is also factorable. You could have also solved using completing the square, but completing the square would have said subtract the 9 over and do the stuff. But here's the thing. You know what 6 divided by 2 squared is? It's 9. It would have made you this perfect square trinomial again. This is a perfect square trinomial. So I'm going to solve using square roots. It's also just as good to solve by factoring, I think. Completing the square would have been redundant. You'd go right back to where you are. Completing the square is fine. You would have just gotten right back to where you are. So this can already factor down. This is x plus 3 quantity squared. A benefit of knowing your perfect square trinomials for a single problem. Take the square root of both sides. You get x plus 3 is plus or minus 4. X is negative 3 plus or minus 4. Negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. Solving by factoring would have been totally fine. I'd have to first, however, subtract. So let's see, here's square roots. I would have, for factoring, I'm not going to use quadratic formula. Subtract 16 over x squared plus 6x minus 7 equals 0, and that's refactored to x minus 7, or x plus 7 times x minus 1. And you get x is negative 7, and x is 1. So you still get the same answers. I don't know, maybe it was one less step or something. They both work. And like I said, completing the square would have just, you would have gotten right back to where you already were. So that was 37 to 44. I very much enjoyed those problems, and I understand that they have it in this section because we already hit all the other sections where we solved using other methods. Okay, numbers 45 and 46 on error analysis. We'll describe and correct the error in solving the equation here. I can already see an issue. So as this is set equal to 0, we're in good standard form. B is negative 7. So when we do x equals negative b, we take the opposite of negative 7. This should have turned into a plus here. Let's see if there's another issue. Negative 7 squared is 49 minus negative. So 4 times 3 times negative times 6. 12 times 6, 72. 49 plus 72 is 121. That's what they got. And then the plus or minus O over 2 times 3. So everything else is good. They and negative 7, I'm sure there's only one error. Negative 7 plus 11 is 4. Divided by 6 is 2/3. Negative 7 minus 11 is negative 18. Divided by 6 is negative 3. Okay. The one issue was this guy right here. 7 should have been positive there. So, and now you see students do that. The main reason is we say negative b, we say minus b, but if b is already negative, we're really saying the opposite of b. We got to change the sign. They never change the sign of negative b in the formula, and the negative 7 remained as such instead of, I would say as such, turning it into 7. So let's work off of what they would do from there. The opposite, I kind of wrote it. But now let's get the x equals 7 plus or minus 11 all over 6. So 7 plus 11 over 6 is 18 over 6, which is positive 3. And 7 minus 11 over 6 is negative 4 over 6, which is negative 2/3. So the signs change here as well. And I imagine that would just happen each time that we do something like that. All right, number 46. I think I know where they're going to go with this. Let's see what they do. Number 46. Negative 2x squared plus 9x equals 4. Now, I'm not a fan of them using this negative here. I guess they luck out because they have to do some rounding. But what I'm seeing is their choice of 4 as c. They chose to use 4 as c, and I'm gonna guess that's the only mistake. So using 4 as c is a problem because c isn't 4. C is negative 4, at least in the way that they have things written. Now, I personally would prefer to make a positive, which keeps 4 positive, but then it changes b negative. So their c, they didn't get their equation in standard form set equal to 0. They didn't set their equation equal to 0, and assumed that c should be the same value on one side of the equation as it would on the other side of the equation. Which is totally not true, right? The sign won't change. So if I were to fix it, honestly, I'm going to add 2x squared over and subtract 9x. Hope you don't mind. I don't refrain from my ways. That negative 4, and by the way, I'm not big on the rounding thing at the end anyway. So I got negative 2x squared plus 9x equals 4. I'm going to add 2x squared over, subtract 9x over, and I get 2x squared minus 9x equals, plus 4 equals 0. Plus 4 equals 0. So 4 is still positive, but now 2 is positive and 9 is negative. And I'm going to work off that discriminant. So b squared minus 4ac, which is 81 plus 32. 32? Yeah, which is 113. 113 is probably a prime number there. So x equals negative b, so now 9 plus or minus the square root of 113 all over 2 times 2, which is 4. So now here's what they have that's different, right? Besides the... Wait a minute. Am I good on that? Add, subtract. If they had that... We're good, right? Because we... I just want to make sure I'm correct, because now I feel like I shouldn't have the same discriminant. I shouldn't have the same answer as them. I should have something different. So let's see what I just goofed up here. I added that. I subtracted that. That all looks good. I think this A being negative is throwing me off and making it kind of weird. So, G. Let me pause and make sure that I'm good, because I shouldn't get the same answer as them. Okay, I gotta look back better at my work. This is an 81 minus 32. It's 81 plus 30. Or it's not plus 32, it's minus 32. I think I was kind of going off of... I think I was thinking I should have been getting the same answer as them. Which is totally wrong. So that's 49. Okay, hey, this is gonna fix things a lot more. It must have meant this was factorable. I didn't pay attention to it. Actually, it totally is. We had a problem like this before. So square root of 49 is 7, right? Let me write a 7 here. 9 plus or minus 7. So if I fix this problem, I said, here's the problem. This is factorable. 9 plus 7 is 16. And 16 over 4 is 4. So x is 16 over 4, which is 4. Or x is 2 over 4, which is 1/2. Okay. Number 47. A fountain shoots a water arc that can be modeled by the graph of this equation, where x is the horizontal distance in feet from the river's north shore, and y is the height in feet above the river. Does the water arc reach a height of 50 feet? If so, about how far from the north shore is the water arc 50 feet above the water? How far from the north shore? Okay, so... 47, we have y equals negative 0.006x squared plus 1.2x plus 10. We are basically, does it reach a height of 50? We're trying to see if y equals 50 here. That's the basic crux of this thing. Now, from here, does it reach a height of 50 feet is really a question on... When I set it equal to 0 and stuff, do I have solutions? So I'm going to work more toward the discriminant portion. If the discriminant's positive, yes. If the discriminant's 0, yes. If the discriminant's negative, no. Now, as I subtract 50 over, heck, I'm going to add this over, you know me. 0.006x squared minus 1.2x and subtract 10 and get plus 40 equals 0. I'm hard-pressed to believe that this will equal 0. I'm not quite sure. If I multiply everything by 1,000, I get 6x squared minus 1,200x plus 40,000 equals 0. I don't know what it is about me that really prefers to see numbers this way. I just do. I'm going to divide everything here by 2. 3x squared minus 600x plus 20,000 equals 0. It's once again kind of me asking, does it hit? Let's see. Let's try the discriminant. B squared minus 4ac, which is 360,000 minus 240,000, which is 120,000. I think I did that right in my head. Well, listen, it's positive. So if it's a positive discriminant, then it indeed hits. So yes, it hits. That's the kind of part A question. So yes, it hits. How far from the north shore is the water arc 50 feet above the water? So now we're solving for x. Okay, now that 120,000 is the part that goes inside the square root. At this point, I'm going to use the calculator. So negative b, so 600 plus or minus the square root of 120,000 all over 2 times a, which is 6. So I'm using this part of the equation from it, the way that I use the discriminant. This is where I'm going to use the calculator as well. I'm only going to be doing the plus. So let's do 600 plus the square root of 120,000 all divided by 6. And I'm getting 157.735. So about, let's just do the plus. No, I'm sorry. There's probably a minus involved. Let's double check because it can hit both ways, right? Of course. Let's look at the minus as well. Yeah. Okay. So there are two different answers here. So x is either from the minus version, 42 point, let's say 27 feet, and 157.74 feet. So this far away from the North Shore or whatever. So that's where it's going to hit the 50. Okay. This graph seems to represent that as well. I'm not sure if this is drawn to scale, but here's 20, here's 40. 50 would have been like right here. So apparently it hits totally. That totally works. All right. That is just one problem on 47. You know we're going up to number 82, right? So let's keep moving. 48. Oh, and this is multiple parts. That's good. Between the months of April and September, the number y of hours of daylight per day in Seattle, Washington can be modeled by this. I find the questions very interesting. I really do. This is researched, or it's used in such a way that they have models. The news station, the weather stations probably have models of these things, and it's relevant. I don't remember the information, but there it is. The only one I remember is if we talk about like the Gateway Arch, where it's like 630 feet tall as it is and wide or something like that. X is the number of days since April 1st. Do any of the days between April and September in Seattle have 17 hours of daylight? If so, how many? I think you're going to see me use these numbers this time when it comes to because that's multiplying by something too big for me to kind of want to work out. If I subtract 17 over, well, I'm going to make these positive, but if I move this stuff over, I'm going to have minus 0.076x, and then I'm going to do subtracting the 13, so plus 4 equals 0. Boy, I don't know. I'm not a fan of writing the I need my numbers whole. 5 over, so what is that? Multiplying by 100,000. So I'm going to get 46x squared. I'll redo some of this. This is my only problem. I'm really bad at doing this. 7600x plus 400,000. Like that. I can at least divide by 2, so I'm going to go for that. 23x squared, unless these can all divide by 23, minus 3800x. I don't know why it's worth it for me to do this. I'm just not in the mood for using those other numbers. Look, big numbers are also just as troublesome. But discriminant b squared minus 4ac. No matter what you do, you're dealing with big numbers, or you're dealing with weird numbers. 4ac. Let's compute that. I'm getting negative 3800 squared. I'm just going to outright compute it. Minus 4 times 23 times 200,000. I only hope I did my decimal shifts right. If it's way off, we've got to talk about that. So I'm getting negative 396,000. So I got to make sure I did all my numbers right when I multiplied. So 0.00046 times 100,000. That would be 46. 0.076 times 100,000 is 7,600, and obviously 4 times 100,000 is that. So that's all good. So listen, the discriminant was, now it's a large discriminant because I made the numbers big, right? So the discriminant's about, so it's okay that I have a big discriminant. Let's just put it that way. Negative 396,000. 200,000. Yeah, I typed everything in right. Yeah. As long as my signs are appropriate, added that over, subtracted that over, subtracted that over. Yeah, all good. So what are they asking? Do any of the days have 17 hours of daylight? No. Do any of the days have 14 hours of daylight? All right. Well, all that extra work. All that extra work would turn 17 into a 14. So for part A, here's that. For part B, it's not going to be much different actually. But instead, this is a 14 equals that stuff. And then when you subtract 13 over, then it equals 1. So if it equals 1 instead of a 4, then this is 100,000. So we will then have, and you divide it by 2. So I'm going to deal with this. So dot, 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 dot. So 23x squared. Sorry, guys, I'm going in just kind of my fast fashion with these numbers. 100x plus 50,000. We're taking half of that equals 0. Now for the discriminant, we're going to be doing b squared minus 4ac. This is probably where you have a proper value. At least I can plug this in the calculator that way now, because I already have that previous input. So 50,000, like this. And yes, now I'm getting a discriminant of 9840000. So yes and 2. You'll get two times in the year. When that happens, they don't ask you what those days are. This is just a discriminant question. This is whether the discriminant's positive or negative. So I was probably fine using the decimal versions. I just kind of work things out my way. 17 hours of daylight's probably quite a bit anyway. Okay, number 49. Making an argument. Your friend uses the discriminant of the equation 2x squared minus 5x minus 2 equals negative 11. And determines the equation as 2 real solutions. Is your friend correct? Explain your reasoning. I'm going to guess that your friend probably didn't set this equal to 0. So I would agree that if this was set equal to 0, or if this was A, B, and C, that having a negative y-intercept with a positive stretch factor would indeed have 2 x-intercepts, 2 real solutions. But if we add 11 over it here, it's questionable. We have to go ahead and see if our friend worked out the fact that when you do this to it, this isn't going to work. Your discriminant is going to be negative 5 squared minus 4 times 2 times 9, or 25 minus 72, which is negative 47. Negative 47. Your friend is not correct. Your friend is not correct. Explain my reasoning. Friend should explain their reasoning. Your friend is not correct. Wait, your friend incorrect. Is my friend? My friend is not correct. Is it a he? I don't know, just my friend. My friend likely evaluated the discriminant of the equation, or of the expression, on the left side of the equation when it was not yet set equal to 0. Once set equal to 0, you get a negative discriminant value. Thus, you will have no real solution, or 9, no real solutions, 0 real solutions. Oh, friend, sometimes you're right, sometimes you're wrong. We really got to work on this, friend. Number 50. The frame of the tent shown is defined by a rectangular base and 2 parabolic arches that connect the opposite corners of the base. So kind of like, if I see it from this thing, it's like connecting and connecting like that. Makes sense to me. The graph y equals negative 0.18x squared plus 1.6x models the height, y in feet of one of the arches, x feet across the diagonal of the base. Can a child who's 4 feet tall walk under one of the arches without having to bend over? Oh, when there's no tent there? All right. So we're going to set, so we got y equals negative 0.18x squared plus 1.6x. We are going to set y equal to 4, because that's going to be the height for this thing based on any x feet along the diagonal base. So from one corner kind of into the middle, and we got to figure that out. Yeah, we got to figure out when this arch thing kind of hits that. We could also kind of work out the vertex of this, but I'm not going to do that. Plus 1.6x. Let's add that over. So 0.18x squared. Subtract this over. Minus 1.6x plus 4 equals 0. That's a 0.18, excuse me. Multiply everything here by 100. I get 18x squared minus 160x plus 400 equals 0. I can divide everything here at least by 2 and get 9x squared minus 80x plus 200 equals 0. Fine by me. All right, let's go ahead and evaluate the discriminant and see if there are any such values. B squared minus 4ac. One of the reasons I like doing this is I can often do this with mental math. So this is 6,400 minus 36 times that is 7,200, which is negative 800. No, a child. This child's face will conk across its nose will just thwack this thing probably. No to that question. Your child will have to bend over for this with a negative discriminant. I'm sorry. I said this the wrong way. I totally said this the wrong way. Negative discriminant's not a bad thing in this case. In this case, that means that the child who's 4 feet tall will not intersect with the arch. If it doesn't intersect with the arch, that's a yes. That's a yes. Your child can do it. If it doesn't intersect, it doesn't bang into it. So discriminants being negative is a good thing in this case. Or it's not good, but it affirms. It's the affirmative. It works for our answer. Really got to think about that. That's probably why they asked the question. In exercises 51 and 52, use the area given to find the value of x, then give the dimensions of the rectangle. So we are going to take a rectangle with an area of 91 square meters. We have 2x plus 3 meters here and x plus 2 meters here. And we are going to find the value of x, then give the dimensions. So we are going to multiply base times height, 2x plus 3 times x plus 2, and set it equal to 91. Excuse me. Let's FOIL this out. We get 2x squared plus 4x plus 3x plus 3 times 2 is 91. And let's subtract 91 over. We get 2x squared plus 7x minus 85 equals 0. Quadratic formula. It's time for us to work that out. It's maybe factorable. 85 is 5 times 17. Hey, are we allowed to solve using any method? Are we allowed to solve using any method? Minus 5 plus 17. Minus 5 plus 17. Because that would work. That would work. We'd get x equals 5. It doesn't tell us how not to do it. Listen, there was a whole... Listen, I'm going to say this. Look, right below this, comparing methods. We just talked about things before where we're referring to methods. This isn't just about quadratic formula. How many discriminant things have we done? I'm going to save myself some time. If it's factorable, guys, I'm going to do it. I found the factorization. Oh, by the way, this would have been x equals negative 17 over 2, which we're not going to have negative x's. If we're talking about different methods, and that's a part of what this whole thing's about, I mean, I'm not lying. That's literally what part of the whole thing's about. I'm going to use it. I'm going to justify it that way. Apologies, but I'm not using quadratic formula for that. X equals 5. So the dimensions are, we have a base of 2 times 5 plus 3, which is 13 meters. And we have a height of 5 plus 2, which is 7 meters. 13 times 7 is 91. All right, that is number 51. Number 52, I mean, I'm yawning. It's late. So if I can factor, if I find the factorization, I'm gonna use it. Another rectangle, we got area of 209 feet. And then we have 4x minus 5 and 4x plus 3. This is feet and feet. Okay, so the area, base times height, 4x plus 3 times 4x minus 5. is 209. That is 16x squared minus 20x plus 12 is minus 8x minus 15. Subtract 209 over and we'll get 16x squared minus 8x minus 224 equals 0. 8 can factor out of all of these, or divide. Let's divide by 8. You'll get 2x squared minus x minus... I'm not good with 8s and these. Give me a second. 28 minus 28 equals 0. Let me try that again. 8 times 28. Yeah, minus 28 equals 0. I'm going to test the factorization. It seems legit. Yes. Plus 4, no, minus 4 plus 7. Negative 8. Yeah. So, hey, if I... Here we go. Negative 7 halves, no good. But x equals 4, you betcha. So that is x. The base is going to be 4 times 4 plus 3, which is 19 feet. And the height is going to be 4 times 4 minus 5, which is 11 feet. And 19 times 11 is 209. So that works out. Oh, this is square feet, by the way. Okay. That is 51 and 52. Now we're going to get into some of those methods again, right? So I just talked a little bit about them. We get to keep going. In 53 and 54, solve the equation. Oh. Got to use all three methods. I'll tell you what, solving by graphing is not going to be my preferred method. So this is, they're making us do quite a bit here. So 53, 3 methods in 1. We're going to solve x squared plus 4x plus 4 equals 0 by graphing. By factoring in quadratic formula. So I guess, listen, if it's if we solve by graphing, we're going to have to assume it's factorable. Otherwise, we won't be able to see where it intersects. When it comes to graphing, you have some options. I'm going to say it straight up, guys, right now. This is, well, I'm going to use the negative b over 2a. Otherwise, if I factor that, I'm giving away all the secrets of factoring, right? X is negative b over 2a, which is negative 2. The y value is negative 2 squared. Remember, we're graphing as if it's y equals this. So negative 2 squared plus 4 times negative 2 plus 4, which is 4 minus 8 plus 4, which is 0. So your vertex is at negative 2, 0. The question on this thing, and I kind of just answered it right now, is what are the x-intercepts of the graph? So it's at negative 2, 0. The y-intercept is 4, so I should be hitting like that. And I am. And then I'm kind of going up like that. Right there. So there's the graph of this thing, but the solution to this was, where did this cross the x-axis? It hit at one place, and that was x equals negative 2. So x-intercept of negative 2, x equals negative 2 is the solution. That's solving by graphing. I do not prefer that method. Too long for something I guess I already knew the answer for by factoring. So if I do factoring now, I'm going to take x squared plus 4x plus 4 equals 0. And let's factor this down to x plus 2 times x plus 2, or x plus 2 quantity squared. Therefore, x is negative 2. That's my preferred method for this particular problem. Quadratic formula, where a is 1, b is 4, c is 4. We're going to start with the discriminant and get b squared minus 4ac. We've seen this a lot, which is 16 minus 16, which is 0. Now x equals negative b plus or minus square root of b squared minus 4c all over 2a, which is negative 2. Wasn't bad. Wasn't bad at all, given it was a perfect square trinomial and small enough numbers, and that I'm not starting with the quadratic formula and plugging those things in until it wipes out. Negative b over 2a was totally enough. Factoring preferred. Factoring preferred. It's easiest. It's fastest. Not for everybody. Preferred does not have 2 F's. No, it's just fastest. This is how I'm working it out. Again, if it's factorable, I'm going to say factoring's preferred for this one as well. But number 54. Oh, they're not making me graph this. Okay. Okay. They didn't even make me graph this in in the equations where we solve by graphing. Like, I mean, for the whole section. You guys see what we're going to do here? We have, for solving by graphing, we have the vertex x value at negative b over 2a. That's negative 11 over 6. Not only is it that, but now we got to substitute that in for y. So 3 times... I don't know how to plot negative 11 over 6. It's basically negative 2, but it's not. Now, I could factor it and find the intercepts, but then that's factoring. Right? It's not graphing. I mean, they're probably saying use a table, plug numbers in until you get it. We got to find a vertex, though. We still got to find out where it bottoms out. 3 times 121 over 36, that's squaring that, plus 121 over 6 plus 6, which is 121 over 12. 3 over 36 is 1/12 plus, excuse me, this is negative here, so this is a minus here. I don't want to mess this up. Minus 121 over 6 plus, now 6 is 36 over 6. I'm going to go ahead and put that right now. Oh, excuse me, 72 over 12. 72 over 12, because what we're about to do is get a common denominator. This 121 over 12 minus 121 over 6 is negative 121 over 12. And plus 72 over 12 is 49. Oh, at least that's not bad. 49 over 12. No, it is. We're not taking the square root. So is negative 49 over 12. Okay, so your vertex is at negative 11 over 6, comma, negative 49 over 12. Okay, that's around, it's just less than negative 2, and that's just less than, and it's just to the right of negative 2 and just below negative 4, so kind of like that. Now this is, it's so close that I might as well just put it right on it. This is over 1 up 3. I don't even know if this is factorable. Over 2 up, I mean 6 is a y-intercept, but over 2 up 12, oh, maybe it is factorable, but okay, I gotcha. If I reflect this over, it's kind of like here. And then up 12 is, I guess, kind of there. I don't know. It's not perfect. But, okay. So, this graph is kind of just doing a bunch of this. Now, the graph, the point it's probably, I don't know what it's for sure hitting on this. I'm going to make an educated guess. But my educated guess is this one is probably hitting exactly at x is negative 3. This one I do not know. But I know it's going to be something over 3. Maybe 2/3? Negative 2/3, because it's got to be something divided by 3, because we got it, one thing factors out with the 3, so it's probably negative 2/3. That's I don't know. I'm not going to plug, they're going to plug in the right fraction in to get it. Maybe. Let's go and solve by factoring. We have 3x squared plus 11x plus 6 equals 0. I haven't tried to factor it yet, so let's try that. 3x and x. This would have to be the 3. If this is 3 and 2, it would work that way. 9 plus, yes, that works out. So yeah, negative 2/3 and negative 3. Yeah, I totally preferred graphing. You can see how opinionated I am when I do my videos. Quadratic formula. Quadratic formula. Discriminant is b squared minus 4ac, which is 121 minus 72. Oh, here's that 49, by the way. So there's 49. That's where this works out. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 11 plus 7 is negative 4 over 6, which is negative 2/3. And x equals negative 11 minus 7, negative 18 over 6, which is negative 3. Now, factoring preferred for myself. If you looked at my work, you might make a case for saying, oh, I'm not sure if I know the factoring, so quadratic formula. But if you want quadratic formula to be as efficient as I made it, you would have to start with the discriminant and cut all the corners that I'm cutting. If you copy and paste, if you use everything straight from the formula itself, it's going to take a while, and I don't know how fast you can calculate some of those things. If you can factor it, guys, go for it, especially when they give that. Number 55. How many solutions does the equation ax squared plus bx plus c equals 0 have when a and c have different signs? We talked about this. So this is one where I even cut corners on a problem here. So when they have different signs, remember, I'm going to explain it first. If a is greater than 0 and c is less than 0, remember what c is. It's a y-intercept. So if a is greater than 0, it's a stretch factor. It says you go upward. So you're going to have two solutions, two real solutions. Now, if a is negative and c is positive, if a is negative and c is positive, then you're above the y-axis there and you're going downward. Not above, but you have a y-intercept above. You have two real solutions, here or here. That's my answer. That's my reasoning. So that's it. But yeah, so we don't have to test discriminants on those if we're trying to see how many solutions there are. We'll just know automatically. We can't guarantee it for the other ones. If A and C are the same sign, we can't guarantee. We have to test it. When the discriminant is perfect square, are the solutions of ax squared plus... I've been answering this all day. Are the solutions of ax squared plus bx plus c equals 0 rational or irrational? Explain your reasoning. So I've been stating this all day. Perfect square meaning obviously it has to be positive. So when the discriminant is a perfect... See, they should have been... I like that it's an exploration here, but it should be taught. When it's a perfect square, you will have rational solutions. That's because the discriminant is inside the square root. Discriminant is inside of the square root. And the square root of a perfect square is a rational number. And then you're only dealing with rational numbers after that, right? Yeah. Only dealing with rational numbers after that, so it's all good. Okay, 57, 59. Okay, numbers 57, 58, 59. Give a value of c for which the equation has two solutions, one solution, and no solution. So x squared minus 2x plus c equals 0. Now this is open-ended. But I wonder how much we can work this out and talk about what it would specifically be by going for the discriminant like this. We need to look at b squared minus 4ac. b squared minus 4ac. And we want to check and see when it's greater than 0, less than 0, things like that. So that's 4 minus 4c. We want to check when 4 minus 4c is greater than 0, 4 minus 4c equals 0, and 4 minus 4c is less than 0. Now, once I answer one of them, it kind of addresses the other ones. So let's do when it's equal to 0 first. 4 minus 4c equals 0. Let's add 4c to both sides. Divide both sides by 4. You're going to get 1 equals c. So when c equals 1, so let's get rid of this part. When c equals 1, you'll have one real solution. When c is 1. When 1 is greater than c, right, this is the b squared minus 4ac, or when c is less than 1, you'll have two real solutions. So we are looking, so two real solutions, and when 1 is less than c, you'll have 0 real solutions. They said give a value of c. So for 2, we're going to say c can be, 1 has to be greater than c, so c can be 0. For 1, c would have to be 1, and for 0, c would have to be 2. There we go. Hopefully that made sense with what I did. If not, right now I'm just doing the problems and saying things out loud. Let's do the same thing for this one. I need to find a better way of writing out those test parts, though, because it got a little iffy at the end. So x squared minus 8x plus c equals 0. You know, the part that I didn't like was writing the inequality with the number on the left and a variable on the right, but it had to do with the way that we wrote the parts. So excuse me. Let's look at the discriminant of b squared minus 4ac, which is 64 minus 4c. So if I add, so let's say this is set equal to 0, right? If I add 4c over, I get 4c equals 6. Well, I want to write what I was saying before, which was test when 64 minus 4c is greater than 0. Here, we'll do this one at a time. This time I'm going to subtract 64 over. So negative 4c is greater than negative 64. I tried to avoid this, but I can't. Divide both sides by negative 4. Here you get c, here you get 16, but you have to flip the inequality. When you divide by a negative, the inequality flips. So for a two real solution case, c has to be less than 16. For example, c could equal 10. Okay, there's an answer. For one real solution, because otherwise I'm testing things all the time for whatever things, and I don't want to do that. I could, you know what I could do is I could work off completing the square, and then I could choose numbers that are bigger and smaller. Oh, I should have just done that. I'm working more with the discriminant, though. This is more of a quadratic formula set. We got to check. So this is where c equals 16 for that case. And then for no real solutions, c would have to be greater than 16. So how about c equals 20, like that? Kind of open-ended. All right, number 59. See, I don't want to complete the square with this, even though I don't want to complete the square here. So discriminant, we're going to do 144, 12 squared, minus 4 times 4 times c. So discriminant is 144 minus 16c. So now we got to check and see for two real solutions when 144 minus 16c is greater than 0. Subtract the 144 over and divide both sides by negative 16. You'll get c is less than 9. So we could say c equals 5, for example. For one real solution, this is very scattered work, I know. One real solution, c would have to equal 9. And for no real solutions, c would have to be more than 9. So how about c equals 12? Okay, see, now it's basically doing a shift of your numbers, shifting it higher or lower. High enough so that it goes above the x-axis, just enough so that it hits it, or low enough so that yada, yada, yada. All right, let's keep moving forward. Number 60, because we're past 2 hours. I need to finish around 3. Use the quadratic formula to solve an equation. You obtain solutions that are integers. Could you have used factoring to solve your problem? Explain your reasoning. Yes. Yes, if we have rational solutions, integers are rational solutions, which means it was factorable. As long as they're not irrational, that means it's factorable. Part B, you obtain solutions that are fractions. Could have used factoring to solve. Yes, same reason. Fractions are rational solutions, which means it was factorable. As long as it's rational, it's factorable. Yes, fractions are rational solutions, which also means it was factorable. Don't undermine the use of factoring something when you're able to. Make a generalization about quadratic equations with rational solutions. I have. I'm ahead of the book. Quadratic equations with rational solutions are factorable. Now, when do you know that you have rational solutions? If your discriminant is a perfect square. Positive perfect square. Good question, though. We've been talking about it. So I've been abusing what the book's been telling me to do. One thing, I've already been doing it the other way. Number 61. The fuel economy, y in miles of a car, can be modeled by the equation y equals that, where x is between 5 to 75. And x is the speed of the car. So we drive between 5 and 75 miles an hour to be talking about how this fuel economy works for the car. Find the speeds at which you can travel and have a fuel economy of 32 miles per gallon. Y is miles per gallon. Okay, so y is negative 0.013x squared plus 1.25x plus 5.6. Let's set y equal to 32 negative 0.013x squared plus 1.25x plus 5.6 equals 32. Let's subtract the 32 over and change all the signs. I can do that at once. So minus 1.25x, subtract that, so I'm going to get a positive now. So plus 26.4 equals 0. Sorry about that, just kind of working things out my way. Multiply everything by 1,000, and we get 13x squared minus 1250x plus 26400 equals 0. I have no reason to believe anything can factor out of that, so let's just leave it how it is. Let's go for the discriminant to begin with. So they say find the speeds. We're going to have to actually solve for x here. But let's start with b squared minus 4ac. And this is not what I'm not going to... I am going to use the calculator. Equals... Let's see. Where's my calculator? So I got... Again, I forgot to bring a calculator home. That was the one thing. It was the one thing I said I was supposed to do on the last time out. So 4 times 13 times 26400, and we get 189700. 189700. This is the thing that's going to go inside the square root. That's not the answer. So the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac. I have no idea what I mean, I can factor out 100, but I don't know if 1897 is a perfect square of any sort. All divided by 2a. 2 times 13 is 26. So I imagine the plus and the minus are going to work here because they say the speed or speeds. And so it's just one of those things. We're seeing a couple of them actually work out. So 1250, let's start with the minus. Let's do the square root of that previous answer and divide it by 26. I know you're not seeing any of my calculations. Sorry about that. So 31.3. So x is about 31.3. What was this? Miles per hour? Miles per hour will get you around 32 miles per gallon. I like this kind of model stuff. And then I just don't like that. It's late and it takes a while. This other one will be 48.3. 48.3 miles per hour. So when we use both of those there. So there's an optimal place somewhere in between where you max out the peak miles per hour. And it makes sense, you know, fuel economy, if you're too much on the gas pedal, you're just consuming too much over that time. But if you're not too much on the gas pedal, you're just not going far enough to get some miles done over those hours. All right, the depth d in feet of a river can be modeled by this equation where t is between 0 and 7. And t is the time in hours after a heavy rain begins. So depth feet of a river. When is the river 6 feet deep? So we got d equals negative 0.25. By the way, if any of these are factorable, I'm going for it. Remember that. If I can see what it's factorable by. So 6 feet deep. Let's find what times. Again, I'm going to add this stuff over. So 0.25 t squared plus, minus 1.7 t minus 3.5. So plus 2.5 equals 0. Now I would have multiplied everything by 4, but 1.7 times 4 doesn't fit the bill. So let's multiply by 10 first and see if we can do anything from that. Looks like we can. Wait a second. By 100. By 100. So 250. There we go. I can divide everything by 5. So 5t squared minus 34t, I think, plus 50 equals 0. I think that's right. All right. Is this factorable? I don't think so. I don't think so. All right. So we... I don't think so. Discriminant. B squared minus 4ac. All right, let's see. 34 squared. I don't know what that is. Minus 4 times 5, 20 times 50 minus 1,000? 50. 156. So not a perfect square, which means this was not rational. It means it wasn't factorable. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, 2 times 5. Boom. Let's go ahead and work this guy out. When is the river 6 feet deep? Let's see if there's more than one answer here. Let's try 34 minus the square root of 156, all divided by 10. And I'm getting 2.15. So x is about 2.15 hours. I feel like you kind of got around that and not say just 2 hours. And then let's do the plus, and let's see if we stay within 7 hours. 4.65-ish. So 4.65 hours. So yeah, that's within 7. So more than one answer. A lot of these have had more than one answer recently, which is kind of cool. It's not just restrict one and that kind of thing. All right, next exercise is 63 to 68. Tell whether the vertex or the graph of the function lies above, below, or on the x-axis. Explain your reasoning without using a graph. Thank you. I don't want to use a graph. So 63, y equals x squared minus 3x plus 2. Now, sometimes I'll do the discriminant. Sometimes I don't have to, things like that. I can use any means necessary. Here's how I'm going to do. I'm not going to do discriminant. This is factorable. This factors into y equals x minus 2 times x minus 1. What does this tell me? The vertex. So first of all, the a is 1, so it's an upward facing graph. It has 2 x-intercepts. The x-intercepts look nothing like that. It has 2 x-intercepts at 2 and 1, which tell you the vertex is below. Vertex below. Because it has x-intercepts of 2 and 1. We totally could have done discriminant, but I'm going to use any method I care to. And that's what I care to do. If it's factorable, I'm going for it. 64. Y equals 3x squared minus 6x plus 3. There's a GCF of 3, which actually does kick things off. 3 times x squared minus 2x plus 1. This is a perfect square trinomial of x minus 1 quantity squared. If you know anything about anything, guys, this is vertex form. The vertex is at 1, 0. You know what that means? Vertex on. It's on the x-axis. When I say on, that's what I mean. 65. I see a GCF. Let's see where we go from there. Y equals 6x squared minus 2x plus 4. I can factor 2 out, and I'm left with 3x squared minus x plus 2. 3, 2, 1. Yeah, y is 2 times 3x and x. What am I seeing? Oh, never mind. That's a plus. Oh, yeah, that's not factorable. Okay, so not factorable. As far as dividing 2, it's 6x squared minus 2x plus 4 equals 0. Now I'll divide out the 2 instead. 3x squared minus x plus 2 equals 0. So, okay, not factorable. Let's go for the discriminant then. We'll do b squared minus 4ac. Yeah, look at that. This thing's a no-go, right? This is going to be 1. Sorry, oh, my desktop background changed. I was wondering what changed blue. 1 minus big boy, 24. So negative 23. So it's an upward-facing graph. It was an upward-facing graph. This is not touching the x-axis at all. This is vertex above. Vertex above. No real solutions. That doesn't necessarily mean it's always above. You have to see which way it faces. Like these two are 66 and 67. You can see the a is negative. So number 66, y is negative 15x squared plus 10x minus 25. I will attempt to factor. Let's start with GCF talk. Negative 5 factors out, and we get 3x squared minus 2x plus 5. Also not factorable, so let's ignore what I just said. Well, sort of. I'm going to divide. I'm going to set everything equal to 0. and divide everything by -5 to get that same thing. 3x squared minus 2x plus 5. Let's go for the discriminant, where we are going to do b squared. I think it's the same thing as before. B squared minus 4ac, which is 4 minus a big number, 60, which is -56. So it's not going to touch. However, it doesn't touch, but it's below this time because it's a downward facing graph. So this is below, vertex below, for a different reason. Doesn't touch, but downward facing, right? Downward facing. Number 67. We have, oh, did they say without graphing? Without using a graph. Well, so I'm not using a graph. I'm showing you what the graph is telling you, if that helps. F of x equals -3x squared, because I'm not plotting points, plus 8. I want to see if this is factorable. I got to first factor a -1 out, though. 3x squared plus 4x minus 8. So let's see. 3x and x, even numbers, 4, 2, 2, 2, 4, 6, 4, no. 4, 12, no. I don't think it is. I don't think it's factorable. So let's go ahead and let's set this equal to 0. I'm going to set the opposite version of it. 3x squared plus 4x minus 8 equal to 0. So let's try the discriminant. We'll do b squared. I just did b squared. B squared minus 4ac, which is 16 plus 12 times 8 is 96, which is 112. Yep, not factorable. Not factorable, but two real solutions. Two real solutions, but it's a downward facing graph. So with a downward facing, I don't care where the solutions are. Just the vertex is above. Vertex above. Like that. Two real solutions with downward facing. Last one, number 68. That's a perfect square trinomial. I just know what they look like. So this one here is plus. We haven't seen vertex on in a while. 9x squared minus 24x plus 16. This is a perfect square of 3x, a perfect square of 4, and this is double, 3 times 4. So this is 3x minus 4 quantity squared. Now this isn't vertex form, but it's the same concept of vertex form. It's a perfect square trinomial, and set equals 0. There's only one solution. I could have factored a 3 out in some capacity here. This is a vertex on the x-axis. Whether it faces up or down doesn't matter. This is vertex on. Because one real solution from perfect square trinomial. Okay, that is that set. Let's go to 69. NASA creates a weightless environment by flying a plane in a series of parabolic paths. The height, h, and feet of a plane after t seconds in a parabolic flight path can be modeled there. Hey, look, they use whole numbers. I don't have to do anything with them now. I get to use them. Great. So h is -11t squared plus 700t plus 21,000. Passengers experience a weightless environment. Yep. When the height of the plane is greater than or equal to 30,800 feet. For approximately how many seconds do the passengers experience weightlessness on such a flight? Explain. Okay, so this one's kind of interesting, where we're going to get our solutions, and then we figure out t is the time in seconds. We got to figure out the difference between our two solutions. If it's from 2 seconds to 6 seconds, they're weightless for 4 seconds, like that. So we're going to set 30,800 equal to this guy. Let's, I'm going to make this positive. So 11t squared minus 700t. Subtract 21,000 over, and so we'll get plus, I don't know why I'm so bad at this math, 9,800. Yes, I think so. Equals 0. All right, I don't know if that's factorable. I'm not going to bother. So the discriminant there is b squared minus 4ac, which is, well, 700 squared is 490,000, I think, minus 44 times 9,800. So 58800. I doubt that's a perfect square. 58800. So t. I don't know how many times it was a t when I've been writing an x, so I don't know. But t equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, there will be two answers, right? So we're going to do 700 minus... Shoot, I got to put parentheses in the beginning. 700... Sorry. Minus the square root of 58800 divided by 22. So one of the values, one of the times is... The smaller of the times is 20... What do they ask us to round to? They don't really. 20.796. I'm just going to give a few numbers. Seconds. These aren't the answers. We're going to find the difference between these times. And the other time is 42.840. Now we got to do one minus the other. Weightlessness is about 42.840 minus 20.796, which is about one minus the other. I don't know how to put this. Sorry, I'm trying to get it exact here. So approximately 22.044. 22.044. I'm sure they're gonna say 22 seconds. About 22 seconds. So my explanation is, once you find, because when we're solving for that thing, we're finding when it hits that height. So when we set h equal to 30,800, we find the times when we are at that height. If we subtract those two times together, we hit the interval when the passengers experience weightlessness. So we're going to subtract and find that out, and that's what we did. Okay. About 13 more questions here. Number 70. Use the numbers to create a quadratic equation with the solution solutions x equals -1 and x equals -1/4. Okay. Blank x squared plus blank x plus blank equals 0. It says to create a single one of the quadratic equations. Well, I'm going to do it this way. If I have x equals -1, then x plus 1 is a factor. If I have x equals -1/4, it's not x plus 4 that's the factor. I multiply both sides by 4. I get 4x equals -1, so I get 4x plus 1 is a factor. So factor and factor. So for an equation, I could say x plus 1 times 4. I'm going to write the other one. 4x plus 1 times x plus 1. So here's one I could write. If I FOIL this thing out, I'll get 4x squared plus 4x plus 1x is plus 5x plus 1 equals 0. So that's one version. So I could use this, 4x squared plus 5x plus 1. Are those options? Yes, we could use those there. We could also make everything negative. We could say -4x squared minus 5x minus 1 equals 0. And that should also work out. I don't see any other versions with those numbers that we're going to use, but those could also be used in some way. Great. Number 71. A rancher constructs 2 rectangular horse pastures that share a side as shown. The pastures are enclosed by 1,050 feet of fencing. Each pasture has an area of 1,500 square feet. Is there a question? Oh. Show that y equals 350 minus 4/3 x. Let's draw this out. I want to see what I'm looking at, or what I don't know what they talked about when they said show that this equals this. So x, this is x and y. They're rectangular. So, and they're equal. Show that y equals 350 minus 4/3 x. So 1,050 feet of fencing. So this fence, so we have 1, 2, 3, 4 x's and 1, 2, 3 y's. So we have 4x plus 3y equals 1,050. Oh, this is where that comes from. Okay, so we subtract, to solve for y, we subtract 4x from both sides. So we get 1,050 minus 4x, divide both sides by 3. This is part A. Y equals 350 minus 4/3 x. All right, that's good. That's part A. Part B, find the possible lengths and widths of each pasture. Okay, we can use this to express the 350 minus 4/3 x to express that in terms of y. So when we multiply x by y, the pastures each pasture has an area of 15,000 square feet. So x times y equals 15,000, or x times 350 minus 4/3 x equals 15,000 as well. So that's where this guy kind of comes from, right? So let's distribute x. We get 350x minus 4/3 x squared equals 15,000. And automatically I'm doing a couple things. I'm going to multiply everything by -3. If I multiply by 3, it gets rid of the fraction. If I multiply by negative, it makes this positive. So I'll get positive 4x squared minus, here's my 1,050 again, minus 1,050x equals negative 45,000. Let's add the 45,000 over. 4x squared minus 1,050x plus, I'm running out of room, 45,000 equals 0. And I can divide everything by 2. 2x squared minus 525x plus 22500 equals 0. I don't know if that helps or hurts my numbers that I want to do. I'm going to copy and paste. I'm just going to kind of scrunch it up a little bit here. All right. So I have no idea if that's factorable. Let's go to work. Discriminant b squared minus 4ac is 8 times. I only hope I did all my mental math correctly there. So my discriminant's going to be 95625. That smells like a perfect square, is it? No, it's not. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac. I only hope I have the correct numbers, all divided by 2a. So it says possible lengths and widths. You can probably do the minus and the plus. Now I'm kind of sick of having so many of these. I want to get a little less work, if possible. Square root of 95625 divided by 4. So here's the minus version where I'm getting about 53.94. I'm going to round to the nearest whole number. I think it's only going to be fair. I don't know. Maybe not. 53.94. Okay, I'll just put that. Feet. And the other one is about 208.56 feet. Let's see if there's anything wrong with saying those numbers. If there are 4 x's, boy, that's very little fencing for y. I guess it still works out. So let's do y equals on both of those now after the fact. So if we do those, we can look at y equals, let's put these over here. Okay, now y equals 350 minus 4/3 x, right? So y is 350 minus 4/3 of 208.56, and y is 350 minus 4/3 of 53.94. Okay, so on this one, we're going to get, what do they want? Possible lengths and widths? 350 minus 4/3 of 208.56. So 71.92 feet. So here's one of the sets like that. Sorry, I'm really crushed for room on this thing, the way that I want to write this. And then the other one, I'm out of the binder paper space. Let's get the other one out of here, or for you. And let's do that. We're getting 278. So the other one for this is y is about 278.08 feet. So that's the other possible lengths and widths of that. So those are just, it says of each pasture. So that's going to be that there. Okay, wow. I'm going to move on from that problem. Because they weren't clean numbers. I think maybe I had a wrong number somewhere. I'm sorry if I did. All right, number 72. Well, I could try and multiply blank times width. I'm not going to. All right, number 72. A kicker punts a football from a height of 2.5 feet above the ground with an initial vertical velocity of 45 feet per second. Write an equation that models the situation using this. So, yeah, totally. We have h equals negative 16t squared plus v naught is 45. That's your initial velocity. That glitched. Plus 45t. 2.5 feet above the ground. S naught is the initial position, 2.5, initial height, like that. So that's that. B, the football is caught 5.5 feet above the ground as shown in the diagram. Find the amount of the time the football's in the air. So, okay, 5.5 is on that side, is negative 16t squared plus 45t plus 2.5. Now, there are two answers to this that we're going to get. We have to choose the bigger one. So when it comes to plus or minus, we're just going to do the plus, and that'll say how long it's been. Because otherwise, it's rising up when it hits 5.5, which is very, very close to nothingness. I'm going to add 16t squared over, subtract 45t over. You can see I'm a big stickler to that. Subtract 2.5 over, and set it equal to 0. Nothing in factor, excuse me, this is not a GCF. Trying to think of something can factor. 16 times 3 pushes it kind of close. I don't think anything here can factor. So let's go straight to it. Discriminant, b squared minus 4, minus 4ac. 45 squared, isn't that 2025, what's 45 squared? Yeah, 2025, darn it. Minus 12 times 16. I don't even know what that is. But when you subtract those, you get 1833. 1833. So t equals 45 plus or minus the square root of 1833 all over 2 times 16 is 32. Now, I'm not going to do the minus version. Let's just do the plus one because we need to get when it goes far out and when it's caught. So 45 plus the square root of 1833 all divided by 32. And I'm getting 2.7. This is a short punt. 2.74 seconds. I hope I did everything right, but 2.74 seconds. That's not a good punt. I think they normally have like 5 seconds of hang time or something like that. Maybe I'm over exaggerating, but even that's a high school punt. It's a kicker. It's not a punter. That's the problem. All right, so I believe it's that. I hope I did that right. All right, number 73. The solutions of the quadratic equation ax squared plus bx plus c equals 0 are x equals negative e plus and negative e minus, the plus or minus part, Find the mean of the solutions. How's the mean of the solutions related to the graph of y equals? Well, I've mentioned this several times now. The mean is the average. It's the midpoint of these two numbers. So how do you average these two things? You add them up and divide by 2. So if we're going to go the long version, I mean, hopefully you already know what this answer is. Mean equals, so we're going to do negative b plus, again, the book's doing all of the teaching for you on these things, which were very relevant earlier. And plus this one, negative b minus, all divided by 2. There's no better way to put that, or there is a better way to put it. I probably should. Dividing this by 2 is putting the 2a as a 4a. I'm just going to do that right now. 4a. Negative b plus negative b is negative 2b. And plus this plus negative that means these parts cancel out. So you get negative 2b over 4a, and that reduces to negative 1b over 2a. So the mean is negative b over 2a. How does that relate? How's the mean related to the graph of this? The mean is related to the graph of y equals ax squared plus bx plus c by being its vertex. Axis of symmetry. Axis of symmetry. Now this is important. The quadratic formula having negative b over 2a then does this plus or minus square root of b squared minus 4ac over 2a says from negative b over 2a, from the axis of symmetry, we are adding something and we're subtracting something to get, say, x-intercepts or points on the graph that are the same distance away from that axis of symmetry. That's why the negative b over 2a on there is a crucial understanding of that. Or when you have a discriminant of 0, that's why it's important why your solution is just negative b over 2a, because in that particular instance, it is, the vertex is the solution. The vertex is the x-intercept, and that's what we do. So it's cool. It works out. Okay, how do you see it? We match each graph with its discriminant. Explain your reasoning. So what do I match it with? Oh, right here. So graph A, I'm not going to draw any graphs or anything like that. I'm just going to go and write answers. Graph A, graph B, graph C. Now there are letters for these. I guess we write these out. Graph A is a vertex on the x-axis that has one x-intercept or one real solution. That's when b squared minus 4ac is greater than 0. Yeah, you know, I can graph this. It's like that. I just said greater than 0. I don't know why I said that. I read the first one. It's when it equals 0. It's when it equals 0. Explain your reasoning. One real solution. One. Did I actually say explain your reasoning? I feel like yeah. Can I say it? One real solution. Discriminant is 0, one real solution. B, graph B, I have these backwards. I have to put this here, this here. There we go. All right, graph B is this guy above the x-axis, not touching. That's when b squared minus 4ac is less than 0. You have negative numbers because there are no real solutions. Sorry for really fitting this in like this. And C, when this graph is touching the x-axis twice, it's two x-intercepts, or two real solutions. So b squared minus 4ac is greater than 0. Two real solutions. All right. Number 75. You are trying to hang a tire. Swing. You're trying to hang a tire swing. To get the rope over a tree branch that is 15 feet high, you tie the rope to a weight. To get the rope over a tree branch, 15 feet high, you tie the rope over a weight and throw it over the branch. You release the weight at a height of 5.5 feet. What is the minimum initial vertical velocity needed to reach the branch? Hint, use the equation. Yeah. So, 15 feet high. So we have h equals negative 16t squared plus v naught t plus, I'm going to use 5.5 feet for this. We are going to substitute 15 in for h, and we need to solve for v naught plus v naught t plus 5.5, or again, add this over, 16t squared. Doesn't matter if v naught's positive or negative. Well, it does. I'm going to write minus v naught t. Subtract 5.5. So plus 9.5 equals 0. Oh boy. I think I'm comfortable with the decimal this time. It's just, it's not that in the way. You know, I can multiply everything by 2. 32 I'm not making things better for you guys. That's the problem. Minus 2 times V naught T plus, okay. I'm not making things better for you guys by doing that. I'm just going to go ahead and, you know what? I'm going to leave it on this side here. So V naught is exactly the number. Let's subtract 15 this time. I'm actually going to suck it up, and it's not so bad that A is negative if I'm not using the whole quadratic formula. I agree. I admit it. So let's do minus 9.5 equals 0. Okay. We're good. We can do this. We can deal with a decimal. No problem. I use the calculator anyway. I need to find out the minimum initial vertical velocity needed to reach the branch. I need to find out when the vertex hits the x-axis. You know, when I have one real solution. So I need to find out when, for discriminant, that when b squared, v naught squared, minus 4, all these negatives, AC equals 0. That's my goal. So I'm going to solve using square roots. So V naught squared minus a negative, minus the opposite of a negative is minus. So 64 times 9.5. Isn't that 608? Let's say 9.5, 608. Minus 608 equals 0. We're going to add 608 to both sides, and we'll take the square root of both sides. So V naught equals the square root of 608. No plus or minus. We're not throwing it downward. We're only throwing it upward. So the square root of 608. And that's somewhere between 24 and 25. So square root of that 24.65. Now we have to round up no matter what we do here. 24.66 miles per hour. Is that what we're saying? Feet per second? Wait, what are we doing? Feet per... I don't know how many... I don't know if this is seconds. I assume it's seconds. So it's not miles per hour. It's feet per second. Feet per second. It's better to probably say 25 feet per second, because then that way we know that we don't hit over the branch. So one or the other is going to kind of apply how you round. Okay, that works for me. All right, number 76. Sorry I didn't put my little marker on that 75 there for you, though. Number 76. Consider the graph. This should have a plus or minus here. Plus or minus. Consider the graph of the standard form of the quadratic equation, then consider the quadratic equation given this. Write a graphical interpretation of two parts of this formula. I just explained that on the previous problem. So, check this out, guys. We're taking the quadratic formula and splitting the over 2a part. You know how it says all over 2a? That's because it has a common denominator. Now they're splitting this part of the common denominator. So they're giving the over 2a parts here. It's basically this. Let's make this actually look good. I have graph axes like this. Let's say I have some parabola. Don't I have a quadratic tool? It's like... I thought I had a parabola tool. That's all right. Let's say I have some sort of like parabola that does like this kind of thing here, right? Well, there's an axis of symmetry, okay? There's an axis of symmetry that cuts in the middle of these. Maybe it's like this, all right? Now, this is where x equals negative b over 2a. Well, these solutions here are where you add the square root of b squared minus 4ac over 2a. And this is where you subtract the square root of b squared minus 4ac over 2a. So you take what negative b over 2a is and you add and subtract it, and that's where you get your solutions from. Oh, they said write a graphical interpretation. Well, I drew it. So you write it. So x equals negative b over 2a. So x equals negative b over 2a is the axis of symmetry of your graph. The x-intercepts are when you add to the right and subtract to the left the other fraction bit of the quadratic formula. So when you add and subtract those amounts, that's, remember, they're equidistant, right? It's all about that symmetry, and that's where you get those x-intercepts. Another thing that's kind of just taught within. I love it. Find the sum and product. Oh, wow. Then write a quadratic equation whose solutions have a sum of 2 and a product of 1/2. What? All right, 77. All right, well, the sum, we kind of already got that from before. Let's take care of that. So let's see, 77. Oh, sum and product's not going to be too bad. Product's a difference of two squares. But the sum, we're going to have negative b plus the square root of b squared minus 4ac. Listen, this is all over 2a, right? But whatever. Plus negative b minus the square root of b squared minus 4ac all over 2a. They really explore. The questions are great. What they're exploring is really good. I mean, they had a lot of word problems with those decimal things, and that really had me live off these for a while. Negative b minus b is negative 2b. That's over 2a. The plus this and minus this cancels that out, so we're just left with that, or negative b over a. Negative b over a. So that's the sum. The product is, listen, we have a difference of two squares. Well, this is negative b plus the square root of this times negative b minus the square root of this. Now, on the bottom is just, the bottom works separately, like as in we multiply the bottom part separately, over 2a over 2a. So on the bottom, we're going to get 4a squared. 2a times 2a is 4a squared. On the top, we're going to get the top squared, b squared minus root b squared minus 4ac quantity squared. So just that. When you do this squared minus that squared, the square root of something squared is just that thing, so we get that. So b squared minus b squared plus 4ac, when you distribute the negative, over 4a squared. Whoops, over 4a. I've been writing 4ac so often. Over 4a squared. B squared minus b squared is 0, and you're left with 4ac over 4a squared. 4ac over 4a squared. 4 over 4 is 1. A over a is 1. You're left with c over a. C over a. So there's the product. So we need, write an quadratic equation whose solutions have a sum of 2 and a product of 1/2. So we need, what was the first one? Negative b over a. Negative b over a needs to equal 2. And c over a needs to equal 1/2. If I don't know where they want me to go with this. Write a quadratic equation. So I need to, if I multiply both sides by a, I'll get negative b equals 2a. Divide both sides by 2. I'm trying to see where I want to go with this in general. Okay, this can be over 1. Okay, how about this? Let's grow this proportion. So it's negative b over a equals, let's call it 4 over 2. That way, when c over a equals 1 over 2, then I can let a equal 2. I don't know if I'm really doing this right, but a can equal 2. Boom. C can equal 1. And if negative b equals 4, then b equals negative 4. I don't know if that quite works, but I think it does for me. So if that works, then I'm going to have y equals 2x squared minus 4x plus 1. Solutions have a sum of 2 and a product of 1/2. Let's see if that works. I'm going to solve that by quadratic formula. Discriminant b squared minus 4. There's probably another way to do that last part that I wasn't really thinking about, but that's okay. It's kind of late. 16 minus 8, which is 8. So x equals negative b plus or minus the square root of, so that's fine. B squared square root of b squared minus 4ac. 2 root 2. 2 root 2. All divided by 2 times 2, so 4. And those can reduce, and you'll get x equals 2 plus or minus root 2 all over 1. All over 2, excuse me. Root 2 all over 2. 2 plus root 2 over 2 plus 2 minus root 2 over 2. The root 2's cancel. You get 2 plus 2, which is 4. 4 over 2 is 2. So that is the sum of 2. Sum. Product. You get that difference of 2 squares. 2 plus root 2 over 2 times 2 minus root 2 over 2. Bottom is 4. On the top, you get 2 squared minus root 2 squared, which is 2 over 4, which is 1/2. Yes, that was a check. So yes, this is the answer. This is an answer to that one. I used it out of proportions at the end there. Okay, 78. Writing a formula. Derive a formula that can be used to find solutions of equations that have the form ax squared plus x plus c equals 0. Use your formula to solve negative 2x squared plus x plus 8 equals 0. So I wonder if okay, so ax squared plus x plus c equals 0. So in this case now, my b is 1. B is 1. So I'm not going to go the discriminant talk. I'm just going to go straight into it. X equals negative b plus or minus the square root of b squared, 1 squared, minus 4ac all divided by 2a. So it's going to look now like that. Okay. So I don't know if this is plugging in one for b. Use your formula to solve this. So now I plug in that for a and that for c. All right. So it's quadratic formula. I don't know if I'm saying this right or wrong with this. That seems good to me. X equals negative b plus or negative 1. Excuse me. The formula is 1. There's no b. Plus or minus the square root of 1 minus 4. Oh, that a is negative. Oh no. A. Oh, c. This is the hard part. All divided by 2a. It's not hard. You guys would get it wrong when it comes to reducing a fraction, right? 1 plus or minus the square root of 1 plus 64, which is 65, all divided by negative 4. Here's the problem with this answer. You don't want this 4 to be negative, so we got to divide everything by negative. We got to switch all the signs. That means switch plus or minus to plus or minus. It gets a little weird looking, but it's just basically turn that into a positive. Turn that into a positive. That's what we want. I guess that's it. Those are the answers. I mean, that would have been the answer anyway. I don't get the whole derive a formula. If they meant do the completing the square thing to get there, I'm not doing that. But I'm substituting 1 into there to write that version based off quadratic formula. And it looks good. All right, number 79, multiple representations. I think 4 more problems? Something like that? Yeah. If p is a solution of a quadratic equation ax squared plus bx plus c equals 0, then x minus p is a factor. Copy and complete the table for each pair of solutions. So let's actually copy that table over. They're saying that as an example. So yeah, if we have... Now it's weird that this question comes after the one where we did actually have to use the solutions to then create factors. But that's okay. Because that was literally what one of the questions was. It was like, here were solutions, give me an equation. Well, we had to write factors out from it. If 3 and 4 are solutions, x minus 3, x minus 4 are factors, and you can distribute this out. So if one's a solution, negative 1's a solution, then x plus 1's a factor. If 6 is a solution, then x minus 6 is a factor. If we FOIL this out, we're going to get x squared minus 5x minus 6, and let's set it equal to 0 for the quadratic. These are what gives us solutions of that. If 0 is a solution, then x is a factor. If 2 is a solution, then x minus 2 is a factor. You expand that out, you get x squared minus 2x equals 0. Yeah, I don't know why this question comes after the fact. Now, this is the tricky one right here. If negative 1/2 is a solution, I'm going to write this over here. We got to multiply by 2. 2x equals negative 1. And that, therefore, means 2x plus 1 is a factor. You want to write it, you don't want to say x plus 1/2. You want to get into the actual nitty-gritty of that. And then x minus 5 there is a factor, which then leads you to 2x squared minus x plus 1 minus 9x minus 5 equals 0 is that last one. So yeah, multiply this stuff by 2. You get into that set, add 1 to both sides. That's where you get your official factor for it. So we can write it. We don't want a to be 1/2 or whatever. We don't want a fraction. We don't want a fraction. Okay. B. graph the related function for each equation, identify the zeros. I thought I was out of the woodwork. I totally missed that part B. So B, graph the related function for each equation, identify the zeros of the function. So, oh my God. Okay. For each equation, all right. X squared minus 7x plus 12. The vertex x value is at negative b over 2a. I was feeling very joyous until I had to do this. So is 7 over 2, which is 3.5, which is right here. I suddenly felt I just deflated knowing that I have to do this. Really, the problem is I'm hitting the 3-hour mark right now, and I don't know how much room I have on my computer to record the rest of this. I might run out of space. I actually might. So let me pause and graph each one or something like that. Okay, and unpausing, I've got my vertex here. I'll just let you see the work, and I'm going to connect this here. And we are going to see on this first one that I guess it's hitting at 3 and 4 like that. So that's just okay. So that's what we get. So negative b over 2a. So x equals 3 and x equals 4. So what they say? Identify the zeros, and that's what they are. All right, that's the first one. Okay, now I'm going to graph y equals x squared minus 5x minus 6. Give me a moment to write out the vertex stuff. Okay, did a lot of the work for that one here. I'm about to connect the dots and make this happen. Now, the reason I keep pausing again is, number one, I think it's a little bit of downtime. Number two, again, I don't know how much space I have on my computer. Once I hit the 3-hour mark, I know I'm pushing really close to the amount of space I have. And I got 3 more questions after this. So we'll see. I hope I am able to actually fit this all. If I don't, I'm not really sure what to do. Let's get to the next one. Actually, wait, I can't yet get to the next one. The whole point of graphing this was to give you the intercepts. So the intercepts here are x equals 1, or negative 1, which was one of the answers, and x equals 6. 6. Okay, let's get to the next one. All right, here's the next problem. I think I can get through this one a lot faster, because this vertex being at negative b over 2a is at 2 over 2, which is 1. And then the y, sorry, that's the x value. And then the y value, sorry about that. And then the y value is 1 squared minus 2 times 1. 2 times 1, which is 1 minus 2, which is negative 1. So vertex is at 1, negative 1. Sorry, because the other ones were on fractions, so they got a little weird. So this is 1, 1, 2, 4, etc. You can already see where it's crossing. The other ones were really relevant for me to hit what I had to hit, because I had to go, I was on fractions. I couldn't even determine the exact spot where I'd be hitting something. Got a little off. So the fact that I was hitting those spots right on was actually quite nice. But this one hits right at x equals 0 and right at x equals 2. And those were actually the solutions that they had put in for this thing. So x equals 0 and x equals 2. So there's the third one. This last one might take a moment as well because of the kinds of solutions that they had and kind of how that thing's going to look. So let me pause again for that. Okay, so as you can see, this last one's going to be y equals 2x squared minus 9x minus 5. We're going to have to get the x value at negative b over 2a. You can see 9 over 4. So it's going to be a little tricky. 2.25 as an x value. I'm going to go and plug it in and get the y, get the whole vertex for you. Give me a bit. Okay, so I got the y value and stuff, and I plotted the points here. So this is a vertical stretch factor of 2, right? So I went 1, 2. This is at 9/4, by the way. That's 2 1/4. And at negative 121/8, that's negative 15 and 1/8. So I went 1, 2, and then I went 2, 8. Now, and then 3, 18. Because 9 doubled is 18. Now these two right here, that's your y-intercept of negative 5. If you notice me hitting some other random points like that, that's negative 5, and this is 4.5, or 2 1/4, 2 1/4, so 4.5 away there. So that's where those points are coming from. Let's go ahead and go through here and see what it's roundabout when I get these. I forget what intercepts we were supposed to get at the time, so let's see what we get now. I'm not going to plot all the way higher. If it does go higher, that's okay. Forget it. Oh, that got a little skinny. Sorry. So, kind of like that. Okay. So, what are we hitting about? That's a fraction. I think there was a fraction. I think it was negative 1/2, so that actually makes sense. X equals negative 1/2, and that looks like x equals 1, 2, 3, 5. X equals 5. I think those actually might have been the values. That's nice if that's the case. Negative 1/2. Negative 1/2 and 5. Great. Okay, so that's those. So that's number 79. Now, I don't know how many people are watching at this stage. There's a very few that are going to be assigned problems near the very end, especially a question like part B. That was quite a bit to do there. All right, 3 more questions. In 80 to 82, let's see if I have enough computer space room. Hopefully you have enough. Find all values of k for which the equation has 2 solutions, 1 solution, and no solutions. So I think this goes back to what we did before, where we were coming up with other sets of values, but it was like an entire C. So I hope you're okay with my layout when I do this. It'll be just kind of weird here. Where it's all about the discriminant. Discriminant has to be for 2 solutions. Here, I'm going to do like a table. Let me pause this to make a table. Okay, I don't know if this is the prettiest work of art I just constructed. Let me group these together now. But let's see if this kind of works for... Whoa, I missed one. But let's see if this works out for what I want to do. Let's call this 2 solutions, 1 solution, no solutions. So 2 real solutions, 1 real solution, 0 real solutions. And I think once I do the work for one of them, it takes care of the work for the others, right? But we're going to be doing the discriminant. It's all about b squared minus 4ac. In this case, your c is 3k. Now, this needs to be greater than 0. So 1, here, why don't I do it up here? Discriminant is b squared minus 4ac. Okay, so that itself is 1 minus 12k, no, 24k. So here we got to say 1 minus, I don't know if the table is really helpful for me, but it organizes my work. 1 minus 24k has to be greater than 0. If I subtract 1 over, negative 24k has to be greater than negative 1. Divide both sides by negative 24. K has to be less than 1 over 24. Is that right? Do they say find all values of k? So this time we actually write them as inequalities. So k has to be less than 1/24. That's all I got to put, and I'm good. Now, for 1 real solution, k has to equal 1 over 24, interestingly enough. Now, remember, it's 3 times k, but that still makes it 1/8. Okay, so that works out. And then for this one, k has to be greater than 1/24 for that. So, yeah, once you find one of them, I think you're good. I don't really know if that table really means anything for me, but I'm going to do that for the other problems as well. So, number 81. That was a lot faster than number 79. Number 81. Oh, they're in different spots, though. I didn't even notice that. So this one is x squared minus 4kx plus 36 equals 0. I could tell you this one off the bat because this is factorable. I know this one. Hey, if I don't have to do discriminant, I'm not going to. Forget b squared minus 4ac. Actually, it'll give me the same answer. But x squared minus 12x plus 36 would be a perfect square trinomial. So I'm going to tell you what, if k is 3, it's going to be 1 if k is da-da-da or whatever. Actually, I don't know which one's greater than or less than. We might as well do it. So let's talk about the discriminant. Discriminant being b squared minus 4ac, which is 16k squared minus 144. So as far as the table goes, for 2 real solutions, 16k squared minus 144 must be greater than 0. So 16k squared needs to be greater than 144. K squared needs to be greater than 9 if you divide by 16. K, oh, this is tricky. K can be either greater than 3 or less than negative 3. That's how that whole square root business works here. As long as greater than or less than negative 3. Kind of tricky on that. For one real solution, k would have to be -3. So I guess I wouldn't have got that from the things, but I said, no, actually I said 3, didn't I? I guess I was wrong with that. Oh, or the 3. Oh yeah, k is -3 or k is 3. Yeah, both work. So there's that. Now for the no real solutions, k has to be between these. K has to be between -3 and 3 for that one to work. So it's kind of the smaller than this, but greater than the negative. And sorry if you're not really understanding of it. I think I'm nearly out of time on this. I got one more question, number 82. So now it's about A, k squared plus 5x minus 16. This of which would not have a factorable set, so I'm not really sure how to explain it. So so that's why I'm going to use the discriminant. K squared plus 5x minus 16 equals 0. Let's use our discriminant of b squared minus 4a, or k, minus 4kc, which is 25 plus 64k. All right, so this one, for two real solutions, 25 plus 64k is be greater than 0. Let's subtract, 81 was the hardest one. 64k is greater than -25. Divide both sides by 64. Weird fraction, but k is be greater than -25 over 64, which cannot reduce. For one real solution, k has to be equal to -25 over 64. Whoops. And for no real solutions, k has to be less than -25 over 64. All right, guys. That's it, and that'll do it for this one. This is Mr. Robinson. Thank you so much for watching, especially if you got to the end here, man. It's been a very long one. You might not see, if you're watching these like live as they get published, you might not see another video for about another week. I got a lot of other things on my plate going on. Guys, that'll do it for this one. Take care. I will see you in the next one.